Sup guys, welcome to today's show and welcome to this new series about the roadmap to C programming. We're gonna start programming our first program in just a minute, but since this is the first episode, I just want to mention a few things. When you code, you always code for the future. And what do I mean by that? Well, when you write your different commands, they are not being executed at once. You create a file, and that file will be executed later. That's one important fact. And when you program C, this is a three-way process. So first, you write your code, and you do that in a text editor, and you save that piece of code. That's the first step. Step number 2, you compile that code. That means you run a command which will turn your program code into something that the computer understands. Machine code, ones and zeros, and that will create a program. Like in Windows, that's an exe file, for instance. And 3, you start your program. So these are the 3 steps that you iteratively will cycle through all the time. Write code, compile, start program. Write code, compile, start program. And the biggest part of any programming is troubleshooting. This is where you will spend most of your time. Perhaps 50-50 between writing code and troubleshooting. So don't feel discouraged when your program doesn't work, because it doesn't matter what level you're on, you always put in most hours into troubleshooting. That's just the way programming works. Alright, so that's enough of that. Let us create our first program. So you can use any text editor you like. I use Visual Studio Code with a Vimotions extension, but you can use whatever. So I will start this process by creating a new file, and all the files should end in .c. That is the extension. And since our first program will be a so-called Hello World program, I will call this hello.c. And every program has a skeleton. It's a piece of code that you always put in, no matter what you want the code to do. And my skeleton looks like this. I will explain every part of it in just a second. So this is the skeleton for C programming. Every language has its skeleton, and this is for C. So the first line here, the green line, it might have another color or no color at all in your program. This is a so-called comment. And the comment starts with a slash and a star, and they end in a star and a slash. So the characters reversed. Everything in between here is a comment, and this have no effect whatsoever on your program code. I can delete this line and nothing will change. So these are just like labels or headlines. You put in text here to remind yourself of different things, or to explain the code in case something might be tricky to understand or similar. And I always start my programs by putting the name of the file so I know where I'm at. Then we have this include statement, and you might have several of these depending on what you are currently programming. And C is a modular language. That means that you don't have access to the whole language at once, because that would be very inefficient. A lot of the memory would be filled with unnecessary stuff. But you include the stuff that you need for that specific program. So this is the most common include statement, the standard input-output, STDIO. So these are the functions that print things to the screen, that read stuff from the keyboard, open files, and a lot of different stuff that has to do with input and output. And you will probably always use this one. And if you need access to other functions, you will add more include statements. And they always start in this hashtag character. And then you have your include file inside of these brackets. In some cases, you might see this as well. So the same structure, but quotes instead of these brackets. And the difference is where the compiler will look for these files. So if you use these brackets, then it will look for the file in a centralized library. If you use these quotes, it will look for this file in your current directory, the same directory that you have this C file. So basically, when you include your own stuff, you use this way of describing it. And when you use a central library, you use this way. So I will remove this line because I have no file.h. And we will talk more about these so-called header files later on. Alright, then we come to this int main part. And this is a function. And everything in C evolves around function. That is a piece of code, basically. You can have several of these or just one, but you need at least one. And you recognize that it's a function because of these two round brackets. And every program, you can have a lot of different functions doing different stuff with different names. This function's name is main. And you always need to have a main function, because the code that you put inside of these curly braces, that is the code that will run when you start the program. So the main is the entry point to your program. And the return statement is the exit point of the function. Functions can have return values, and that's what's specified after this return statement. We will learn all of that stuff later when we define our own functions. As of now, you can think of this return 0 as exit the program. So for instance, if you put the return 0 in the beginning and you put some code here, this code will never execute, because this return 0 will exit the program, the first thing it does. Alright, so this is the general skeleton. Every time you create a new .c file, a new program, you will always have this stuff. And today it will be a very simple program, just trying things out, and we will print the classical text "Hello World" to the screen, and that's always how you begin a programming course. And you do that by calling another function, which is a library function included in this, which is called printf. And it's called printf because it has the ability to print in a formatted kind of way. We'll get into that more later, but for now we will just do this. Alright, so what does this mean? You might recognize these round brackets, same as after the main function here. And as I mentioned, that shows that this is a function. And in this case, we are calling a function which is already there. So we're calling the printf function because we want to print something to the screen. And we want to print the message "Hello World," so that is what we're putting right here. This new line character at the end, the \n, yeah, that's a new line character. So if you want like to enter down, this is what you put in. So if we wouldn't put this in, it would print "Hello World," and then there would be other text after that. But I can show you later on. Let's start this way. And every piece of code inside of a function, like we are here, will always end in a semicolon. So that is important to remember. Not all languages have these end-of-line characters, but C does. And inside of a function, you always do this. Almost always. I will give you some exceptions to this rule later on, but for now, this is enough. And then I'll put back the return 0 to exit the program. Since this is the end of the file right here, and the end of the main function, it will still exit, but it's good practice to put the return statement in to be explicit of your intent. Alright, so in order to understand this better, I will repeat some things of it. So this is a comment. It has no effect on the execution of your program. This include statement is telling the compiler that we want to use a specific set of functions, which is in this standard input-output library. And the function is printf in this case. This int main statement defines a function with this content inside of the curly braces. What this int means, we will get to tomorrow in the next episode. But for now, you always begin your program with int main, because this is what will be executed when you run your program. And this return 0 exits the program in this case, and this printf statement prints the text "Hello World" ending in a new line. Alright, so let's save this. And how you compile the code depends on what system you're running. I am on I'm running Windows on this computer, but I'm coding against a Linux server, so this is where I will compile my code. I have linked up my VS Code, so it automatically uploads it to this server as soon as I save. But you can compile your code inside of Windows. Almost 100% of my code compiles on both Linux and Windows, and Mac for that matter. But if you want to compile my code in Windows, I recommend downloading a program called Cygwin. That is a POSIX compiler. And I will not get into what POSIX means, but it's a standard for compilers, which is the same as I'm running in my system. Okay, so when we compile our code, we use a GCC command. GCC is the name of the compiler. And we first give it the name of the file, hello.c. And we also need to specify the output file, because this compiler will read the input file, hello.c, and create a program. And we need to name that program. So you do -o space, and then the name of the file you want to create. And the convention is to use the same name as the .c file, but without the .c extension. So hello in this case. And then press enter. And if this happens, that it just moves down to the next line, that means everything has worked. If you have an error in your code, GCC will tell you, but otherwise it just prints nothing. And now you will have an additional file, hello, and you can run that file by doing /hello and pressing enter. And it prints our message, hello world. So what have we learned today? We have learned the basics on how C programming works, the 3-step process of creating your code, compiling, and running your program. We have also learned the general structure, the skeleton, if you will, of the .c file, and we know about comments and include statements. We know about the function main, which executes when your program starts. We know about the printf function for printing stuff to the screen. And we know what the new line character \n is doing. And we do also know how to exit our programs with the return statement. So if you like this episode, please like and subscribe. There will be a couple of these episodes the coming days. So click the bell icon so you will get a notification when I release them. I will also give you a small exercise, and if you really want to learn the C programming, you should do these exercises, because it's not only necessary to learn the actual bits and pieces of the information. You learn programming by programming. So until the next episode, I want you to write 2 more programs of the same kind as this Hello World. And I want you to, well, the first time you do it, you will probably need to look at your old code, but as little as possible. And when you write it the 3rd time, I hope that you can write most of the code without having to look too much. Because you need to put in the most work in the beginning, then the rest will be easy. And you need to learn this skeleton by heart, basically. So when you watch the next episode, you should be able to write this program. Alright, thanks for watching, thanks for tonight.
Okay, welcome back everyone to today's lesson. Today we're going to code our very first C program in Linux. We are going to create a Hello World program, the classical starter project for everyone who's learning a new language. And we are coding in a Linux environment, which I am logged into right now. And we begin by creating a new file, which I will be calling hello.c. And we will be using the text editor nano in order to produce it. So we begin by typing in nano hello.c. Okay, so the first thing that I usually start with is a comment. And you make a comment by doing a / and a star, and then you can type in anything you like. This won't be executed when you compile your code. This is just a comment for the reader of the programming code. So I usually type in the name of the file here. Not really necessary, but I usually do that. And then you close the comment by reversing these two characters. So first a star and then a /. And as you can see, this turns blue in nano, and that says that it's a comment. Okay, so the next thing is our includes. So every C program starts with one or several of these include lines, and basically C is a modular language. It doesn't have a whole lot of built-in functions and commands. It has a few, of course, but not a whole lot. So basically a lot of the stuff that you're going to use will be located in different libraries. So one of these libraries is the standard input, which is included in the libc library. But the stdio, it should be, it stands for standard input and output. And it basically controls how you can print stuff on your screen and how you can read from the user using the keyboard and other similar functions. So basically, unless you are using another library, you are probably always going to include this one. So this is one of the building stones of the skeleton that you will include in every bit of code. Okay, then we come to the functions, and one of the functions that always is included is the int main. Seems like my keyboard is a little bit off. Okay, welcome back. I had a little keyboard problems there for a while, but I seem to figure it out. Or so I thought. Anyway, okay, so here we have created a function, and a function is, you can see that it is a function because there is a pair of parentheses directly connected to the name. So that's how you build your program. Every function does a specific task. You can have one function that adds two numbers together and returns the result, for example. So in order to have a good looking code which is easy to find, and in order to write optimal code, you should use functions like that. So one function per function, so to say. And there is one function which is always included in a C project, and that is called main, and this is always where your program begins. So even if you have a lot of different functions, and even if you have another function on top of this text file, code file, then you will still be starting the program inside of main. So this is where it all begins. And so this code that I have made right here, a comment which is not necessary, but one of the includes and the int main and those brackets. This is the skeleton of your code. So everything you write, at least now in the beginning, will look like this, and then you will put the actual code right here. And we will just have 2 lines of code today, and that will be a call to the printf function, which prints something onto the screen. And I will do it like this. If I can find my backslash. I am having a little trouble with my keyboard today. There we go. Sorry for the delay. There it is. And then we will have one more line of code, and that will be return 0. That is actually not really necessary, but you should anyway always include that at the bottom of your code. What it does in this case is it exits the program. The program will exit when it runs out of lines of code anyway, but it's good to follow the standard and always exit with return 0. That basically means we are exiting the program and everything is fine. If we had some kind of error, we could exit with say 2 or -1 or something like that, but exit with 0 means everything was okay. Alright, so we save this one. Because we use no, then we can see right here at the bottom left, this hat kind of caret symbol means the control key on your keyboard. So Control X will exit. So you hold down the control key and press X, and then you are presented with this question, save modified buffer. It basically asks you, do you want to save this? And we put in a Y for yes, and then it asks us what we want to name the file name to write. And because we typed in the hello.c when we typed in the nano command in the beginning, it remembers that, and it puts this as a default value hello.c. We could change this if we want to edit it somehow, but we will just accept it by pressing enter. So Control X, Y, enter is how you save in Nano. Okay, if we type in ls, we will see our files. I have my ls command alias, so it looks a little different than you. If I do an unalias that, here we go. So we have our hello.c, and now we need to compile the code. So first we create the file, then we compile the code, which makes the computer read our code and create an executable binary file, which is the actual program that we start. So we do gcc, the name of the file, hello.c, then we type in -o for output file, and then we type in a file name. So I usually put in the same thing as the name of the C file, but without the ending .c. So just hello. If we don't get an error, if it just moves on to the next line like this, then it has worked. So if you do ls, now we see we have two files. We have the hello.c that we had from the beginning, and we also have a file which is just named hello. It comes from here. And this is the file that we want to start. And we do that by putting a dot and a slash, and then we type in the name of the file. Hello world. So now we have made our very first program. We have learned how to make comments and how to include the standard input-output library. We have created our main function. We have printed something to the screen, and we have exited our program. The one thing I haven't talked about is this \n here, and that is a new line. So if we haven't typed that in, it would have printed hello world, and then this would have come directly after here. So we most often would want to end our lines with a new line, and that is \n. Okay, that's all for this first lesson. Thanks for watching, and thanks for today.
Sup guys, welcome to today's show. So, yesterday we learned how to create a very simple C program, this one, where we print something to the screen. Today we are going to learn how we can read information from the keyboard of the user. And we will introduce a couple of new concepts as well, where variables are one of them. But first I will create my small skeleton. I will create a file which is called name.c, and I will include the standard IO library and create a main function with a return 0 statement. So this is the skeleton that you hopefully have learned by heart by now. But we are going to include some stuff here, or add some stuff rather. So first I'm gonna put a print f call, which will ask the user for their name. So something like, hello, what is your name? Question mark and new line, like this. This far we came in the last episode. But now we wish to read information from the keyboard. And there is a ton of different ways we can do that. I will use the function SCANF. And this function is a little bit controversial because you should never use it in production code like this because it's not safe. But there's no problem of using it in example code like this. And it's an easy function to begin with. So don't be afraid to use it in codes like this. Alright, but in order to read information from the user, we need to be able to save that information somewhere. And that's where variables come in. A variable is like a small box inside of the computer's memory with a name tag. And they can look like this. So this is a variable with the name name. And what this char is, as you can see, this char gets the same color in VS Code as the int in front of main. And that is no coincidence. Because when we save stuff to the memory, we need to describe for the computer what kind of information it is. So in the case of main, it is an integer. In this case, it basically means that what we return down here will be an integer, like this 0 here. But in this case, it's char. And a single char contains one character. So a single char can contain an A or a B or a dot or a 5, for example. But in this case, we have allocated space for 16 characters. So 16 chars. And this is a variable that we can use to store the name. And we use scanf with this syntax, which might be a little bit confusing in the beginning, but you'll get used to it. So you type %s inside of quotes, and then a comma, and then the name of the variable. So what does this mean? Well, the same way when we create this variable, we need to describe what kind of information it's going to hold, characters in this case. When we use that variable, we sometimes need to describe that again, because this scanf function will not know that otherwise. And this time we use a different syntax, but it's the same thing basically. %s means that the thing that follows to the right is a string of characters. And then we want to produce a result. We need to I want to print to the screen hello and the name that you provided. So the first thing is no problem. We will print hello as we usually do, but then something will follow and then a new line. But what will those things be, the thing in between? Well, the same way we used this %s here, we will use the same syntax when we want to use our variable. So instead of putting something static in here, we will put %s, and this will be replaced with the variable that we specify afterwards. So after this quote, we will put a comma, same way as in the SCANF statement, and we will give the name of our variable like this. So this basically means that instead of just printing hello to the screen, we will substitute this with the contents of this variable. So if we save this thing and we compile it, same as we did before, gcc name.c-o name, it went through. And if we start this program, it says, hello, what is your name? I will type in Jonas, press enter, and it says, hello, Jonas. And this is because we have created a variable, which is a small box inside of the computer's memory with this name tag. And it can hold up to 16 characters. With a note that you can basically just fit 15 characters inside of here, and I will describe why in a later episode. And then we print to the screen, same as before, but then we use the SCANF to read something from the keyboard. So this SCANF function will pause your entire execution of your program until the user has put in a word and pressed enter. Then the program will continue. And it will store this data inside of the variable that we created up here. And you always create the variables at the top of your function. At least if you're gonna follow the rules of C. In later versions, the most recent versions of C, you can actually create variables in other places as well, but I don't recommend it. And then we want to use this variable in the printf, so we use this syntax to express that we wish to replace this position with the contents of our variable, with our saved data. And then we exit the program. So what have we learned today? We have learned what a variable is and that there are different kinds or different types of variable. And we have learned how to read from the keyboard and store stuff in a variable, and how to use that variable when printing to the screen. If you like this episode, please like and subscribe. There will be more episodes coming the coming days, so hit the bell icon if you wish to be notified. Thanks for watching, and thanks for today.
Okay, everyone, welcome to today's class. Yesterday we talked about how to print into the screen, and today we're going to talk a little bit about how to read from the user, from the keyboard. So let's begin by creating a new C file, and let's call it name.c. So I'll begin with a comment telling the name of the file, and then I will create the include and our main function. So this is a skeleton, so to speak, that we will use for all our code. And today we're going to start by asking the user about their name using the printf function, just like that last time. So we ask the user for the name, and in order to save the name from the user, we need to use a variable. So a variable is like a little box inside the computer's memory with a name tag that we can use to store information that we want to use later on. So we will create a variable like this. We'll call it name. Okay, so this has three parts. The first is the char. That's the type of the variable. There are a lot of different types of variables. We have char, which is storing letters and text strings. And then we have int, which stores an integer. That is a number without any decimal points. We have float, which stores a float number. That is a number with a decimal point. And there's a whole lot other ones. In our case, we use a char because we want to store letters in the variable. So char is a type, name is the name of the variable, and we can call it whatever we want. We can call it X, or we can call it ABC. We can't use any like foreign characters or spaces or anything like that, but regular characters and numbers is okay. And then optionally we have a size declared. So we will get into that more when we'll talk about arrays, but for now let's think about this as the total number of characters that we will be able to save inside this variable. Okay, so now we have our variable. Now we want to read from the user's keyboard and store it into this variable. And there are a lot of different ways to do that. Today we are going to use the SCANF method because it's an easy function to use. And we will talk a little bit more about the upsides and downsides of that function later on. So the scanf takes at least two arguments. The first is called a format string. So that is basically telling scanf what kind of variable that follows. So %s, that means a string. We want to read a string of characters. And then we have the name of the variable with an ampersand in front of it. And why do we use an ampersand in front of the variable name? Well, we will get into that later on. It's kind of advanced to discuss this early on in the course, but for now, always use an ampersand in front of the variable name when using scanf. Not when using like printf, but using scanf. Okay, So now we have read the variable from the user. Now we want to use that information. And we will use that information in order to greet the user. And once again, we use this format strings. We print hello, and then we have this %s. And this part will be replaced by the contents of this variable. And then we will exit our program. So we create a variable in order to store information. We print out the question. We read from the keyboard and saves that into the variable. And then we use this, the contents of this variable to print out this message. We save, we compile. And as I mentioned before, when using the GCC to create our program, this is the input file and this is the output file. So if everything goes right, we will have our program in this file. And that's the one that we start with the /. So now it prints out what is your name. I will print out my first name. And it uses that information in order to greet me. So today you have learned a couple of things. You have learned how to create a variable of the type char with a size of 32. We have talked again about how to use printf in order to print onto the screen. We have learned how to use the scanf and the format string in order to read from the keyboard into a variable. And then we have learned how to print that information to the screen. Thanks for watching and thanks for today.
What's up, guys? Welcome to today's show. So today we're going to talk about numbers, integers, and I have created a skeleton for a file called numbers.c, and as always we will put our code inside of the main function. So what I'm going to do is I'm going to ask the user for two numbers, so one at a time. Something like, please input a number in the new line, and I will copy this line, and the second time, please input another number, right? And we know by now that we can use the SCANF function to read data from the user's keyboard. Last time we used it for characters, and now we're going to use it for numbers. So first of all, we need to define two variables. And as you remember, last time we defined it like this. We said char and then the name of the variable and the size. This time we will not need this size, and I will explain later on why. But for now, just trust me. And this will not be a char, this will be an int. That's short for an integer, which is a number without a decimal point. And then we say the name of the variable. I will call this x in this case. And we need two variables, so let's call it y. And there are two ways we can define this. We could either type in another int statement like this, and we can have as many as we need. But since both of these are of the same type, both are integers, there is an easier way, and that is to just list them with a comma in between. And like this, we can have how many we want, like this. Alright, so now we have two integer variables. We have room to store two different numbers. And as you might guess, we will use the scanf in order to do this. And if this were a string, like last time, we would have used this syntax, right? But this is not a string, this is integers. And this s will change depending on the type of the variable. So let me put in a comment here for the type that we know. We know about char, which is a character, and the format string, which this %s thing is called, for, or we should be specific, a string of chars. That is %s. We know that already. Maybe I could type this in the beginning, like so. And then we have something, which is integer. And the first thing that comes to mind is perhaps it's an I for integer, but it's not. It's actually a D. And the logic behind that, I'm not really sure about. But you just have to remember that %s means integer. So let's change this to %d. And this will be our x variable. But there is one more thing we need to change. And that can be a little bit confusing. When we are dealing with an integer variable, we also need to put an ampersand in front of this. And why we need to do that, I will tell you a little bit later, because the explanation is a little more difficult to understand, and it will be confusing at this point. So for now, just trust me and put an ampersand in front of the variable name when we are dealing with integers. And one mistake that is often made is that we put a new line character here. Because we do that at the end of printf statement, right? But don't do it when using scanf. So two things you need to remember when dealing with integers specifically. Add the ampersand, and always when using scanf, no new line after the format string. Alright, so how do we read another number? Well, we repeat the same thing again. So we do scanf and %d, we do an ampersand, and this is the y. So at this point, we will have values, two different values, or the same value perhaps, inside of these variables, x and y. And I'm actually going to define a third variable, which I will be calling result, because I want to do a mathematical operation on these two integers. I want to add them together. And that is pretty simple. if this were mathematics, we would have done something like x plus y is equal to whatever. But it's a little bit reversed when dealing with C programming. We still do x plus y, but we put the result in front. So we say that the result will be equal to x plus y. And don't forget to end with a semicolon. So at this point in time, this result variable will be the sum of these two x and y variables. And then we'll simply print it to the screen like we usually do. We say the result is and %d, because the result is also an integer. And then we put the result here. And as you can see, here we do not use the ampersand. So this might be a little bit confusing. But at this point, only use the ampersand with SCANF and with integers and a couple of others that you will learn. But for integers, you will have an ampersand in front of the variable when using SCANF, but not when using printf. So let's save this and compile. So we'll run gcc numbers.c-o numbers, and let's run this program. Please input a number. I will input 5. Please input another number. I will enter 8. The result is 13. And we are not limited to single-digit numbers. We can enter 55, for instance, and we can enter, I don't know, 9. Okay, this is a little bit too big. 9, 1, 2, 3, 1, 2, 3. 9 million is okay. The result is 9,055,000. So an integer cannot just hold a single digit, like a char, for instance. But there is a limit. And the limit has to do with how the computer is constructed. So if you have a 64-bit CPU, you can basically handle 64-bit numbers. An integer, however, defaults to 32-bit, which means that it goes from 0 to 4.3 billion, approximately. So if you want to use a bigger number than that, this variable will overflow, so it's called. And we will talk more about what that means later on. But for now, and in this specific program, I would say you could use any number between 0 and 2 billion. So half of this. And why half? That I will explain later. Because you have already learned quite a lot today. You have learned how to define integer variables, how to read them using scanf with an ampersand and the %d format string for integers. You have learned that when declaring multiple variables, you can do it with a comma in between if they have the same type. And you can perform mathematical operations by typing the result variable equals and then the mathematical expression. And you can use printf with a %d format string to print the results of the variable. If you like this episode, please like and subscribe. Also hit the bell icon if you want to get a notification, because I will be releasing those episodes quite regularly now at the beginning. And thank you for watching, and thanks for today.
Welcome back everyone to today's lesson. Today we will talk a little bit about how to handle numbers in C, and integers to be precise. We will create a new file called numbers.c, and as usual we begin by a comment, and we include our standard input-output library, and we create our main function. We have talked about the variable type char, which is used to store characters. Today we'll talk about integers, and that the command for creating an integer variable is int. So let's create a variable called x, and let's print out a message asking for a number. Like this. And we will use SCANF like we did last time, but this time with a %d. The format string is %d, and as we did last time, s is a string, %d is an integer. That is a number without any decimal points. And then we will ask our user for another integer. And we will need another variable for that. We could do another int statement like this. That would work. But if this new variable has the same type, namely int, as the last one, we can simply just do it like this with a comma sign between. And like this we can create as many variables as we'd like. So we will have a total of 3. So one called x, one called y, and one called answer. So we will read our second variable exactly like we did the first one. And what are we going to do with these variables? Well, I want to plus them together. So our third variable, answer, will equal x plus y. So if the user inputs the number 5 first time and the number 10 the second time, then the answer will be 5 plus 10 equals 15. And then we will just print that out on the screen. The answer is %d. And we will use our variable answer and exit the program. We compile it like we always do, like this. And that went fine. Okay, select the number. We can use the numbers in the last example. So 5 first, and then 10. And as we can see, the answer is 15. So today we have learned how to create several variables at a time. We have learned the integer type. We have learned the format string %d, which corresponds to the integer type. And we have learned how to successfully add the two numbers together and print out the answer using the printf function. Thanks for watching and thanks for today.
Sup guys, welcome to today's show. So today we're going to talk about decimal numbers. Before we begin, I'm just going to say a few words about the code repo. So if you go to this link, repo.drbirch.com, I have a lot of stuff here, but the interesting folder is this roadmap folder. Here you can download the code that we have created in this series. If you have trouble getting your own code to work, you can look at mine and see what you did wrong. But always try yourself first. Alright, so float numbers, or decimal numbers as they are also called, they are another data type than the two we have talked about this far. Let me create a file, float.c, and I will begin as always by defining a comment at the top. So this far you have learned two different data types. Char, which are used to store characters, and int, which stores integers. But you can't use decimal points in int variables. So if you need to do that, for example, in the code we are making today, that calculates the radius of a circle, then you need to use either the float data type or the double data type. Both of these are for decimal numbers. They differ in how they are stored inside of the computer's memory. And the double data type can also have larger numbers. But they also use up double the amount of memory. Alright, so how do we do this? Let's start by creating our small skeleton, as always. And you might have noticed when I define this main function that sometimes I do it like this. So I put this curly brace on its own line, and sometimes I do this. You can choose whatever you feel most comfortable about. Both are equivalent. So in C, it most often does not care too much about like line feeds or spaces, etc. So you can decide for yourself. All right, so first of all, how do we calculate the radius of a circle? The formula is that you take, the area of a circle. What you do is you take the radius, which is if you start at the middle point and you go to one of the sides, basically. That's the radius. So you take that radius and you times it with itself. So if you have a radius of 5, then you do 5 times 5, and then you times that with the pi constant. And you probably know what pi is, but for those of you who don't, pi is a number which is not exactly 3.14, but it's close enough for us. Actually, there are a lot of different decimal numbers inside of this, but this is what you use. So I'm going to define 3 different variables, and I'm going to use the float data type. So let's have one for the radius, and let's have one for pi, and also one for the result. So let's call it area. And pi we can assign at once because we know that. So we can just do like this. Pi is equal to 3.14. And in some countries, like the northern countries in Europe, uses a comma for a decimal point. But when you code C, you always use the American style with a period sign. Alright, so that is defined. The radius, I think I'm going to ask the user. So I'll use a printf statement, and I'm going to ask the user what is the radius in centimeters. You can use like, I don't know, yards or whatever. Inches perhaps, if you'd like. Alright, and then we need to read that value from the user, and we use SCANF for that, and we use % something, and then we add the ampersand, same as with integer numbers, and then the name of the variable, which is the radius in this case. But what are we going to use as the format string? Well, what kind of format strings do we know? We know %s. That is a string of characters, right? And that's not the one we're going to use. And we also know about %d, which is integer numbers. That's not it either, because then we can't get the decimal parts of the number. And by the way, before I continue, I haven't told you about this syntax when you do a double slash. That is another way of doing a comment. So the difference is when you do this kind of comment, you can have it on multiple lines. So you can have like this, everything is green. However, when you just need to do one line, you can just do 2 slashes, and everything to the right of that thing will be a comment. So you can, for instance, put a comment like this on the same line, describing that line. You can also do it this way, but it's a little bit easier to just put in 2 slashes. Alright, so what format string are we going to use for float numbers? Well, F. It's as simple as that. And if we were to use the other one, the double, then I think I rarely use that. Let me just double check. There is a manual built into well, Linux and Cygwin and most POSIX style environments. So you can do man and a space, and then I'm not gonna go into details now, but you do a 3, and I will tell later on why you do a 3 when we talk about functions. And then you put in the function that you want to read the manual for. And there is a lot of information here. A lot of it is rather difficult to understand at this point, so don't focus too much about this. I just want to find where it lists all the different format strings. So let's see. The double argument is rounded and converted. It's converted in style. Number of significant digits. Well, I suppose you can use either E, F, or G for them. It has a little bit, as you can see, to do how it rounds them and stuff like that. But F will work in this case. So let's put in that. Alright, and one tip that I have, when writing a program, don't try to write all the code in one go, because then you quite often get more errors than if you do it in parts. So I'm going to do like this, that I'm going to stop here, I'm going to put in the return 0 statement, and I'm going to test my code this far. So if it works, it's going to ask me this, it's going to let me input the result, and then it's going to quit. And if that works, then we can continue. So that is an important tip, I think, that you should take into account. So let's compile this thing as we usually do. Oh, I did an error. Conflicting types for pi have double. Okay, I forgot to remove that when I talked about doubles. But this is a good opportunity to talk a little bit about error messages. So you get, when you have an error, you get some pieces of important information. First of all, what file are we talking about? Here we do only have one file, so that's not really interesting. But in big projects, you code in several files, and then it's very important. And the next thing is the line number. So you see it right here, and you see it here as well. And you can see, okay, before, when I had the double here, it talked about line 15, but actually it was caused by line 13. So GCC and other compilers are not 100% accurate when it comes to the line number. So always look more about the error message and this line, perhaps. And when you look at your code, look on the lines above and below as well. Yeah, that's basically it. Sometimes you get warnings instead of errors, and then your program will still compile, but it might not do exactly what you want it to. And sometimes the warnings are wrong. But errors always makes the compilation fail completely. Anyhow, as soon as you have fixed the error, saved the file, you can just run the same command again. And the easiest way is to use the arrow keys on your keyboard and type the up key. Then you can cycle through your old commands and press enter like this. Alright, it compiled. Let's try to run this thing. What is the radius in centimeters? We put in 50. And then the program terminates. So it works exactly as we have anticipated this far. Alright, so let's continue. Now that we have it, oh, I did another error, I see. It should be like this. I reversed these characters. So it doesn't matter what, for how long you have been coding, you will always do these kind of small errors. And big, for that matter. Alright, so now we know the radius and the pi. So let's calculate the area. So the area will be the radius times the radius times pi. Simple enough. And let's print the result. So the area of the circle is, and we do the format string, centimeters. And then we put in the name of the variable, which is area. That's the variable that holds our result. And as usual, when we use printf like this, we don't add the ampersand. So let's save. And let's recompile. And you should always remember to recompile your code every time before you run it again. Otherwise, it will not change. So I'll clear the screen with the clear command, and I will run this again. What is the radius in centimeters? Let's do 50 again. The area of the circle is this thing. And I'm not sure if it's right, but I think it is because the code looked okay. So what have we learned today? We have learned two new data types, float and double, which are similar but stored in memory a little bit differently. We have learned that we can assign variables using this dot syntax for decimal numbers. The %f format string. Yeah, I think that's basically it. This type of line comments. And some things about error messages. So, exercise. Until the next lesson, I want you to create a program which calculates the area of a triangle. And in case you don't know how to do that, you take the height and you, let's see, so I say the right thing. The height times the width, and the result you divide by 2. All right? And try to write as much as possible without looking at the code, but of course you need to look at the code. And if you like this episode and this series, make sure to like and subscribe, because that helps me and it helps others to discover this series. And hit the bell icon if you want a notification when I release the next episode, which hopefully will be tomorrow, seen from the day when you're watching this. All right. Thanks for watching. Thanks for today.
Welcome back everyone to today's lesson. Today we are going to talk about float numbers. And what is a float number? Well, it is a number that has a decimal point in it. So 12 is not a float number, that's an integer, but 3.14 is a float number. So how do we deal with float numbers in C? Well, let's create a file called float.c. Let's include the standard input-output library and create our skeleton main function. Then we will create 3 different variables. This time we will not use the int command. We will use the float command to create float numbers. And these will be pi, they will be round, and there will be answer. And then we'll print out on the screen. No, we won't call this round. We will call it we will call this R. So we will ask the user what is the R in centimeters. And R being like, if we have, I will try my best to draw something that resembles a circle here. It's not too easy using ASCII characters, but if this is supposed to be a circle, then the stuff I'm looking for is what we have here. So it's basically half of the circle cut through. That is R. We call it radie on Swedish. I'm not sure what the English name for it, but something with R most likely. I will just call it R. Maybe I can put it in text on the bottom of the screen what the word is. Anyhow, what is the R in centimeters? Then we will use SCANF with %f as the format string, and %f resembles float, and we will read the R from the user. So this far we have learned 3 different format strings. We have learned S, which is a text string. We have learned D, which is an integer, int, and now we have learned F, which is a float number, a number with a decimal in it. If you want to remove a whole line, by the way, like I just did, you type Control K, like in cut, but with a K. And then you cut the line. You can see it on the bottom of the screen here. Control K, cut text. Okay, so now we know the R of the circle, and we want to calculate the area of the circle, and that would be our answer. So answer equals, and the formula for calculating the area of a circle, that is R times P. And what is pi? Pi is 3.14, right? At least if you round it up. It has a lot of decimals, but 3.14, that's close enough. And then we will print out the answer. So the area is %f. Remember to be consistent with the format strings. If you have %f here, if you have float here, then you should have %f here and float here and here. It has some kind of backwards compatibility between int and float, but my take is that it doesn't always work as intended. Okay, what do we want to print out? We want to print out the answer, and then we want to return. So this is our code, and let's get through it again. We create 3 different variables: pi, r, and answer. The type is float. We print out our question. We use SCANF in order to read a float number into the variable of r. We assign a static value to the pi variable of 3.14, and we use a point as the decimal point. Some languages, like the Nordic languages, they use a comma sign for the decimal point, but C uses the American style one, which is a point. And then we will calculate the area of the circle by doing R times pi, and in order to multiplicate, I think the word is, we use the star sign as a times sign, and we store the answer in our answer variable, and then we will print out the answer by using the %f format string and exit. So hopefully this will compile just fine. Yes, it did. We will start our program. What is the R in centimeters? And let it be 50. And then the area is 7850.0000488, and that is the area of the circle. Well, that's all for today. Thanks for watching, and thanks for today. Welcome back everyone to today's lesson. Today we will learn how to debug our code. And by that I mean how to look through our code for errors and how to fix them. So we have three different pieces of code: hello.c, name.c, and numbers.c. And if we edit the numbers file, and let's say we did a mistake. As we have seen before, almost every line in C, at least inside functions, ends with a semicolon. So what happens if we accidentally miss out on a semicolon? Let's try. We will try to compile our code like before, but this time we get an error. First, let me remove the old executable file. As we can see, I have run the gcc command, but the numbers, we have the numbers.c, but we don't have the numbers without the C, the executable which we start. So if we do numbers, no such file or directory. And that's because if GCC fails with an error, there are two different kinds of errors. There are errors and there are warnings. If we encounter a warning, then the code will still compile, it will produce an executable, and we will be able to start our code. Perhaps it will appear, it won't work the way we're intended to do, but it will compile. However, if we get an error, then it won't compile at all. Okay, so what does this message tell us? Well, it tells us that the error is in the numbers.c file. It claims that the error is on line 11. That's what this first means. It claims that it is. It's not always correct though. Then we get an error message. It says that it expected a semicolon before printf, and then it selects the whole line of, it shows the whole line of line 11, and then there's a little arrow here that points to where GCC has reacted, and it also makes it red if you have colors enabled. Okay, so GCC believes that the error is on line 11. This is line 11, and it points to this function. But look at this. It expected a semicolon before printf. So where's before printf? There's only space here, right? Let's go into the numbers file. And then we can do control dash being this line, and then it asks us for enter a number. I will type in the line 11, and it jumps directly to this line. But this line looks okay, right? There is a semicolon at the end of the line, but remember it said before printf. There is only space before, but remember that C doesn't react. Most often it doesn't react to new lines. So what does C see? This is what C sees. This is what C sees. It sees SCANF and then it sees printf. So that's where the semicolon should be, right? So sometimes you need to interpret these error messages. Now it compiles. Here is the executable. And now it works. So most often C will tell you the correct line where the error happens, but pay attention to the before statement. That can be, and most often is, the line above the current line. Thanks for watching and thanks for today.
What's up, guys? Welcome to today's show. So, today we are going to learn about loops. And what is a loop? Well, sometimes you want to do iterations in your code. You want one thing to happen several times, so to speak. I think it would be easiest to see an example. Let's say I wanted to write a program which asks the user, do you want to quit this program? And if the user presses 1, the program will quit. Otherwise, it will keep asking the same thing. How would you do that in C? Well, one naive way of doing it would be something like this. We create a variable, let's say x, print the message, do you wish to quit? Press 1. Then we use SCANF to read that integer from the user. We check if that x is equal to 1. This is what we learned yesterday. But what do we want to happen in case it is 1? Well, we want to quit the program. And one way of doing that is just using the return 0 statement. There are other ways, but in this case, this is easiest. All right, and if it's not 1, we want to keep doing this. So, as I mentioned, there is a naive way, and that is to just do this. But as you might understand, this will work, but only to a certain degree. If the user presses 0 enough times, you will run out of these, and the program will exit anyway, right? So this is not a viable solution, and it's definitely not a manageable solution. So how do we do it? Well, there are different kinds of loops in C. There are while loops, and let me list them. There are while, and there are do, which are related to while. And then there are for loops. And for loops is a little bit more advanced, so we will wait a couple of episodes for that. And do is basically the same as while, but while is quite simple to understand, so let's start there. We can just do while and then a parenthesis, and we type in a 1, let's say. And then we do one of these, curly brace. And then we want to select, okay, what lines of code do we wish to repeat? And it's all of these, right? So that means you will put the other curly brace after here. So we select everything in between here. And we can also jump out one step, like so. So the code will be easier to read and to understand that this is connected to this while loop. Alright, and then we will just, as we always do, put in the return 0 here. But please note that this return 0 will never be reached, because either all of this will repeat itself indefinitely, or the user will type in 1 and we will quit using this return statement. So we don't really need this, but you should put it in anyway, just to end your main function properly. Alright, so let's go into the right directory, and you can change the directory folder using the cd command. Cd ... means that we move up one step in the hierarchy, and cd space the name of the folder moves into that directory. Alright, so here is our file. Let's compile it, and we can, by the way, if we type just a W and hit the tab, it will fill in the rest for us. So that's one tip. And let's start this thing. Do you wish to quit? Press 1. No. So I press 0. Or I press 5 or 3 or whatever. Anything but 1 will just keep repeating. If we type in 1, the program terminates. So that's simple enough. This is what we call an endless loop. This loop will loop until until the program exits, basically. And this 1 that we have here, this is like a condition in an if statement. As long as this condition is true, we will keep looping. And if we, instead of having like if var is equal to 5, this kind of thing, if we just put a 1 there, that means that it should always be true. Same if we put in a 0 here, that means this should never be true. So if we run this program, it will do nothing. It will not even run this code once, because it checks if this is true, and if not, it just skips over the whole thing. Alright, but let's say we have some message down here, which, let's say that this is important. And as I mentioned, this code will never run, because either we quit with this or it repeats itself. But what if we want to run this code before we exit? Well, instead of this return 0 statement right here that exits the whole program, we can just break out of this endless loop by using the break command, like this. So if x is 1, then we break out of the loop and continue the execution of this program after this curly brace. So we will print this thing. And we can double check that it really works. And if we type 1, it prints our important message. Okay, so that's the while loop. We could also do, by the way, instead of doing this if statement here, we can remove that and put the condition right here. So if x is not equal to 1, then we want to continue looping. But as soon as it is equal to 1, when we type in the 1, right, then the program will exit. So this is the same code as the one we had. And I have a font which makes these symbols when you type in this kind of stuff. But what I'm really typing is this, without the space in between. So an exclamation point followed by an equal sign, that means not equal to. So while x is not equal to 1, do this indefinitely. But as soon as it is equal to 1, break out of the loop. And we can double check that this works. Let's set this x variable first to 0. Right, because if we don't assign a value to a variable, it might have some random value. Because if we don't assign it explicitly, it will just point somewhere in memory, basically, so it can contain anything. So always explicitly set a variable before you use it in a condition. And as we can see, the program still behaves the way we intended. Alright, so what have we learned today? We have learned that this is the correct way if we want to repeat stuff in our code. We are using a loop. And specifically, we're using a while loop. And a while loop works that way that as long as the condition is true, this code will repeat. As soon as the condition is false, then we will break out of this loop and continue execution of the program after the curly brace. We can also quit the loop on our own using the break command, for instance in a if statement. And there are also other loops like for loops and do loops, which we will talk more about later. And we did also learn as a little bonus that we should always explicitly define a variable before we want to use it to something, because it's not automatically 0 from start. Alright, so exercise. I want you to write a program with a loop that uses a countdown. It will first print 10, then 9, 8, 7, all the way down to 0. And when it hits 0, it should print a boom and then exit. Alright? And if you succeed in writing this program, please let me see the code, paste it in a comment. And if you don't succeed and have any questions, please put that inside of a comment as well. If you like this episode and this series, please like and subscribe, and maybe you can recommend it to a friend. And thanks for watching. Thanks for today.
Welcome back, everyone, and welcome to today's lecture. Today we're going to talk a little bit about loops. So a loop is when you select a part of your code that will loop, that will go around several times. So there are different types of loops in the C language, and we are going to discuss the easiest form today, which is called the while loop. So let's create a file called while.c, and as usual we begin by adding a comment about the file name, adding our standard input output include, and creating the skeleton, a main function. And we can talk a little bit about these spaces that I add. So you probably have noticed that inside of this main brackets stuff, I always type in my commands with a space in front of it. And that is not necessary for the code to work. In some languages, like the Python language, it is compulsory, but in the C language you can decide if you want them or not. But especially when you're doing things like loops or if statements, we'll discuss if statements later on in this course, but it will be easier to debug your code, to troubleshoot your code. Plus, it's easier to read, it's easier to understand and see what belongs to what, and stuff like that. So usually when you have one of these open brackets, then you space out one step. And if you have a command here like if a equals 1, then you space out one more step. So that's just a little parenthesis of information. Okay, so today we are going to talk about loops. Why do you need a loop? Well, sometimes you will have a situation when you will let your code do the same thing all over again, and it's not very necessary or good to repeat your code several times, and sometimes that won't solve the problem either. So let me show you an example of a loop. So the easiest form is while.loops. What this means is that all the commands that we put in here will loop indefinitely. So if I put like printf abc right here, and make it like this. Then we save. We will compile. Need to spell GCC correctly. And then we run this code. Boom. It will fill our screen with ABCs and keep on doing it forever. Or until we crash out of the program using the Control-C key. We can almost always abort and quit our program by doing a Control-C. So you would want to avoid these kinds of loops because they use up a lot of CPU resources of your computer, and they are not very user-friendly either. So you always want to make a loop in such a way that you can break out of it. So something like this. I'll create a message. Do you want to quit? Index. Let's create a variable. And we will set x to 0. And then we do you want to quit? Press 1. Okay. And then we will use SCANF to read an integer into the x variable. Okay, so we create a variable called x of the type int. We set it statically to a 0, and then we will ask the user, do you want to quit? Press 1, and read the result into the x variable. Then if we change this 1, which always makes it loop, to while x equals 0. This means as long as this is true, as long as x is 0, we will keep on looping. But if x is anything else than 0, like 1, we will not loop. Okay, let's compile this and run. So if you press 0, it will keep asking the same question. If you don't press anything, okay, if you press 0, it will keep asking. But if you press 1, it exits. So as soon as this statement is not true anymore, we will break out of the loop. But as soon if x remains to be 0, we will keep looping. So this is one way of showing how loops work. It's a little easier to show the rest of the looping related keywords and functions when you have learned the if statements. So we will circle back to these while loops in a couple of lessons. Thanks for watching, and thanks for today.
Sup guys, welcome to today's show. So today we are going to discuss if statement. It is, at least in my opinion, the most important thing in any programming language, because it dictates the logical flow of your program. And regarding the exercise, I hope you managed to create that code calculating the area of a circle, a triangle. I will not go through the correct reply just yet, I mean the right solution. But I would love to see how you solve it. So please take the code and paste it into a comment, and I'll be delighted to look at it. Alright, so if statement. I have created this file called if.c, and let's begin by defining the skeleton, so we have something to work with. Alright, so an if statement has to do with choices. You want something to happen in your code, in your program, if some condition is true. So let's say, for example, that we have an int variable called x, and x is equal to 5. And if x is equal to 5, we want to print some message. Otherwise, we don't want to do anything. So how do we do that? Well, it's actually quite simple. What we do is we type the if command, and then we always have a parenthesis like this. Then we type in the condition. What do we want to check? We want to check if x is equal to 5. But we do like this. So we do a double equal. And why do we do a double equal? Why not just one like in math? That has to do with this. In this case, we are using the equal sign to assign a value to a variable. We want x to be equal to 5. We are making x being 5. In this case, we are not assigning a value to a variable. We are checking if it has a specific value. Do you see the difference? And because these are two distinct types of operations, we use two different symbols for it. So double equal when you compare stuff, single equal when you assign stuff. And then you usually have a pair of curly braces like this. And as you can see, the code editor that I'm using jumps in a little bit. Every time we use these curly braces, same as here in the main function, we jump a little bit to the right. This is called indentation. And that is so your code should be easier to read and to understand what's happening at each level. It's not a necessity though. The code will still work if we don't do it. In some languages, you have to do it, like Haskell and Python. But in C, you can decide for yourself. You can also decide how, if you're using it, how many spaces you want to have, and so etc. All right. So what do we want to happen in case x is equal to 5? Well, we want to print some message, right? So let's print it is 5 or something. And then we return 0 as usual. And the important thing is that everything we want to happen if this condition is true, we need to put inside of these curly braces, because they are linked to this if statement. So this will happen if this condition is met. And we can have several lines of code here, but the code we put after, that will always happen. Same as if we put it above here. Alright, let's try this out. So we do gcc if c-o if, and we run if. And it tells us that it is 5. But if we were to change this to a 4 here, for example, that would mean that this condition is no longer true. What happens then? Nothing. So this line of code will only run if this condition is met. Let's take another example. I will do like this. I will just comment this stuff out so we have it for reference. Alright, so I want to code something which asks the user how fast they are driving. And depending on that value, I want to print different messages. So how do I do that? Well, let's first define a variable that we can store that speed in. So let's call this velocity. And let's ask the user, using a printf statement, how fast are you driving in kilometers per hour? You can do miles per hour if you want. And then we read the number from the user. And this is %d because it's an integer, and we don't forget the ampersand. Alright, so now we want to print different messages depending on the speed. So let's start with if we are driving faster than 100 kilometers per hour, then we want to tell the user you are driving too fast. How do we do that? Well, we do an if statement, and then the parentheses, and inside of the parentheses we should put the condition. And what is the condition? Well, the variable that we want to check, the variable that holds the information we want to investigate, is velocity. So we'll type that in. And this time we are not comparing it to a specific number. We want to check if it's more than that, right? And then we just do this greater than sign. And we don't do it double or anything. It's only the equal sign that we do that with. So if velocity is more than 100, then we do something. And we can either do this, like we did in the previous example, but if we only have one line of code linked to this if statement, we can just put it below like this, without those. So that's a matter of choice as well. Some instructors say that you should always use those curly braces, but I think the code is easier to read without them. So you decide for yourself, but it only works when you have one line linked to it. Right, so you are driving too fast. Alright, so do we want to check anything else? What if we are driving faster than, let's say, 80? Then we want to print something else. So let's do that. If velocity is more than 80, that's the logical thing to do, right? A similar if statement below it. Let's see if that is correct. You are driving safely. And then we save. Alright, so let's compile this thing and try it out. So I'll use my up arrow key to find my GCC and I press enter. And let's run this thing. So let's say I'm driving 30. What happens? We don't get anything. And that's how it's supposed to work, right? What if we are driving 90? You are driving safely. But what if we are driving 120, say? You are driving too fast and you are driving safely. That's not what we wanted, right? Why does that happen? Well, these if statements are considered individually. First we check if it's more than 100. If so, we print this. Then we check if this is true. And then we print this. But both of these can be true, right? If we have 120, both of these are true and both messages will print. But that's not what we want. We want to do either this or this, right? And in order to link those two if statements together, we can use this syntax. So if it's more than 100, then we are printing this message. Otherwise, if we have this, we print this, but not both. So if we save this now, we recompile, we run it, and we say 120, you are driving too fast. So this else condition is a very good thing to use in combination with if statements. We could also add a single else thing without an if after and print something like okay. So if we compile this code and we do, let's say, 120, too fast, 90, safely, 20, okay. So this is a catch-all condition. So if this if statement fails and this fails, then this will take over in all other cases. All right? So this is how you dictate the general logical flow of your program. You can compare the values inside of variables with different things. You can also compare variables to variables. Let's say, for example, we have another integer which is called safe speed or something. And we set the safe speed to, I don't know, 80. and we change this to if velocity is more than safe speed, and this will do exactly the same as the other thing. So you can both compare values directly, and you can compare variables and the value which they contain. All right, that's a lot for one day. What have we learned today? We have learned how to use if statements to dictate the general logical flow of your program. You have learned how to check a condition using the equal sign and the greater than sign, and it's the same, by the way, if you want to check if something is less than. And as a note, there are also less than or equal to and greater than or equal to, so you can combine these. You don't do like with a double equal sign. It's just a single one with the greater than or less than in front. And we have also learned how to do individual if statements and how to link them together using if and else if, and also how to create a catch-all condition using just an else statement. One important note though, when using else if and else, you can't have some other code here in between. These two needs to be following each other. Otherwise, it won't work. And that's about it, I think. I will give you an exercise. I want you to use what you have learned today and try to create a small guessing game where you will ask the user for the answer to some trivia question. Like, what is the capital of Serbia or something? And then you give 3 different alternatives, and the user is going to pick either alternative 1 or 2 or 3 by typing a 1 or a 2 or a 3. And then you're going to compare if it's the right answer, and if so, you can keep a score or something and tell the user afterwards. And if you succeed in building this little program, please paste it in the comments. I would love to see it, and the other users would probably also like to see what each other has come up with. Please also like and subscribe, and if you like this episode. And thanks for watching. Thanks for today.
Welcome back everyone to today's lesson. Today we are going to talk a little bit about if statements. So let's create a file called if.c, and as usual we will build the same skeleton as we usually do. And today we will have a int variable called speed. We will ask the user, how fast are you driving? And we'll do kilometers an hour, like we in Europe likes it. And then we will put that result in the speed variable. Okay, and now we'll come to our if statement. So if looks like this. It's a keyword if, and then there is a set of parentheses. And after that, a set of brackets, just like in a function. Inside the parentheses, we have a statement. So we check if something is true. In our case, we will check if speed is more than 100, and if so, we will print f you are driving too fast. If it's not, then we will print another message. Just the text okay. Okay, so an if statement contains a statement, and that checks if it's true or not. So we are checking if speed is more than 100, then we will print this message. And we can have several lines of codes inside of this. If this statement is not true, then the else statement kicks in, and then we'll print another message in our case. So we'll try to compile this one, and then we will try to drive 50 kilometers an hour. We get an okay back. If we say 90, we get an okay back. If we say 100, we get an okay back. But if we say 101, you are driving too fast. So we can check if it's faster than 100, we can check if it's less than 100, we can check if it's less or equal, bigger than equal, then we have double equal signs, and that's because in C we can assign a value to a variable like this. You have seen that before. Speed should be equal to 100 and will be after this line. But in this case, we are not assigning a value to a variable. We are checking if this speed has this specific value. Do you see the difference? Assigning value, checking if it has a specific value. We can also check if it's not 100. Then we do an exclamation point and an equal sign. That means speed is not 100. Also, we can, if we go back to what we had, more than 100, we can also have several if statements. So if it's more than 100, you're driving too fast. We can have, if it's more than 80, no, let's do, yeah, we can do it like that. If it's more than 80, we will print something like you are driving perfectly fine. So the first check is always if. Then you can have as many else if as you'd like, where you can check different values. And then at the bottom you will have an else statement, that if all these different ifs and else ifs are not true, then the else statement will kick in. Let's try this code. So if we say that we are driving like 200, you are driving, okay, let's begin with less, 50. I think we did something wrong. If speed less than it's troublesome sometimes. Less if speed is more than 100, and this if speed is more than 80 else. Let's try it again. So if it's 50, sometimes when you add stuff to your code, you forget that you have added it. Look at this. I set it so it's always 100. All right, sometimes you need to learn how to troubleshoot as well. All right, where were we? Let's try 200. You're driving too fast. 150. You are driving too fast. What if we do 90? You're driving perfectly fine. And if we do 50, we just get an okay. So today we have learned how we do an if statement. We check if this statement between the set of parentheses is true. If it is true, then we run the code inside of these brackets. If this is not true, but this statement is true, then you run this code, and you can have several of these else if statements. You can only have one if statement. And then at the end, you will have an else statement. So if all these if and else if statement fails, this will kick in. Thanks for watching, and thanks for today. Welcome back everyone to today's lesson. Today we are going to talk about functions. Let's create our new file called triangle.c, and we begin by creating our comment as usual and our include and our main function skeleton. Okay, so I want to create a function that calculates the area of a circle. And the area of a circle is the base times the height. And I'll put this in a set of parentheses divided by 2. So we could easily do that calculation inside of main, but this is a good example of a function. So let's begin by creating our different variables. I want to have one integer for the base, I'll call that b, and then the height is h and the area is a. I want to read the different values from the user, so let's add a printf statement adding base like this. But this time I will not end this line with a new line. Like before, we would have done something like this, right? But this time I want to do it like this. But in the way that the printf function works, it kind of buffers everything until it receives a new line character. And then it prints out everything at once. So if we do print out this line right here without a new line at the end, then it might not show up. It's a little bit arbitrary. But if you want to flush the buffer and print out everything in it right away, we may use the flush function. And we will give the standard out as an argument. So the standard out is a special file descriptor. We will talk more about file descriptors when we create programs that open files on the hard disk drive. But standard output is basically the screen. So these two together will print out the base and then let the user input the value on the same line. So we'll use SCANF like before and read the B value. And then I will do exactly the same for the height. So a printf statement, a flush statement, and a scanf statement. And this time the age variable. Okay, this far there's nothing particularly new. Now we do want to call our function. We will not do the calculation inside of main. And we want the result to be in the a variable. So we do a equals and then the name of our own function, which we will call area triangle. And you may name your functions as you wish, but no spaces or special characters, only A to C, 0 to 9. Underscore is okay. And we will supply two arguments for this function, the base and the height. So basically we call the area triangle function. We supply the base and the height as two arguments, and the result will end up in the a variable. And then we'll simply print out the results. So the area is %d, and then a new line, and the a variable. And then we exit the program. Like this. Okay, so now the main function is done, but we haven't created the area triangle function yet. So if we try to compile this code, we will get a warning first that it doesn't find the declaration of the area triangle, and it points to this. But this is only a warning. But in the next stage, the compilation progress is actually a step-by-step procedure. I will talk a little bit more about that in an upcoming lesson. But in this case, the first procedure only creates a warning. So that would basically be fine. But then the next stage creates an error. And as you know, if you get an error, it won't create an output file. And the error is that it's an undefined reference to the area triangle. Basically, we are referencing that function, and that function is undefined. It doesn't exist. So as you can see, we have our triangle.c, but no executable. So if we go back into this, we want to create that function. And as I mentioned before, this is a function, the main function. So we can't put our own function inside of another function. In some languages you can, but not in C. Instead, you will put your own function above this main function. And the syntax is basically the same as the int main. But this time it will be int area triangle. And the main has a parenthesis that is empty, because the parentheses in a function will hold all the arguments. But in our case, we do need 2 arguments, because we pass the base and the height. So in our function, we need to add that. So we type in int and then the first argument, which is the base, and then the second argument, which is the height. And we need to supply what kind of variable it is. So basically, in the parentheses, we have the input, argument number 1, argument number 2. And the int before the area triangle, before the name of the function, that is the output, that is the return value, which will end up here. So what do we want our function to do? I will create a variable. It's not really necessary in this case, but I will do it anyway just to show you that you can, and it makes it a little bit easier to understand the process. So I will create a variable called area, and I will let area be equal to the base times the height divided by 2. So that's the area of the triangle. And then I will return that value. So inside of main, we usually return 0 when we exit. When we exit our own function, we want to return the value that we want to pass back. So we call our area triangle function. We supply the b as the argument, which will end up here, and the h as the second argument, which will end up here. And then we do the calculations. We create an area variable which does the calculation based on the input variables, and then we return that variable, or the value rather. And that is what the a will be equal to. So in, out, out. If we save this and we compile it again, now it compiled just fine. We start our program, it asks for the base, and as you can see, it asks on the same line. I will type in 50, and the height will be 200, and the area is 5,000. So today we have learned to create our own function, how to let that function take input values and return an output value. We have learned how to call that function and take care of the return value. And we have learned how to print something not ending in a new line, flushing the buffer. And that's basically it for today's lesson. Thanks for watching, and thanks for today. Welcome back everyone to today's lesson. Today we will talk a little bit about random values. So first of all, there is no such thing in the computer world as a random value, at least not a truly random value, because computers are based on logical operations and following different instructions. And that is quite the opposite of randomization. So what we do have is what is called pseudo random functions. Basically, it's mathematical algorithms that is mimicking true randomness. And most often it's basically the same for the end user and for the coder. But if you write advanced encryption software and stuff like that, it might be difficult. Anyhow, let's create a function, a file called random.c. And we begin as usual with our base skeleton. Only this time we are gonna include a little more, but let's start like this. And we will create an int variable, and let's call that random. And we will let random be equal to, let's call it our random function, because we will create our own random function, and we won't pass an argument to that, at least not yet. And then we will just print out the results of this operation, something like this. Okay, so what do we put in our random function? Well, we want it to return an integer, so we begin by that, and then our name of the function. This time empty parentheses, because at least not yet we don't have any input values. And if you don't really know how functions work, please watch our old episode where we talk about functions. Okay, so how does this work? Let's create a variable called x, and we will let x be equal to rand, which is a function that is built into the standard C library. And then we'll return x, like this. Okay, so why do we call our own it should be our random, not out random. Why do we create our own function if we'll just return a function that already exists and nothing more? Well, we are going to build onto this own random function. But let's start here. And we haven't added any includes yet, so we'll see what the compiler says about this. Yes, we do receive a warning, implicit declaration of the rand. In this case, it only produced a warning, which means it did create our file, and it even kinda works. But if we get a warning about implicit declarations, we should fix it anyhow, because in this case C tries to fix it itself, and it kinda succeeded this time, but most often than not it won't succeed, because it will try to fix it in the wrong way and not as you intended it. So if you get this warning message, fix that. Okay, so how do we fix it? How do we know where to find this function and what to include? There is a built-in manual that you can use, and it works like this. Right at the Linux prompt here, you type in man3 and then the name of the function. And why the 3? Because there are different types of manuals. So one is about the built-in commands of the Linux shell, and there are other types of manuals, like for configuration files, we usually do 5 and stuff like that. And there are also 2 different types of functions. There are library functions, like this one, and there are system calls, which are basically the core kernel of the Linux system, the functions of that. And if we want to use one of these functions, we'll use a 2 here. But always begin with a 3, and if it doesn't find it, or if it finds the wrong one, try 2. In this case, it does find the function. And as we can see, it's located in the standardlib.h. So we'll go back to our random.c. We'll include that standard library.h, and we'll compile it again, this time without warning. However, it gives a random value, but it gives the same random value each time we run this. Why is that? Well, as I said, this is not a truly random function, it's a pseudo-random function. So basically it is an algorithm that each time you call the function, I can demonstrate this. If I go into the code and I copy these 2 lines and print them out like this. So we will call that twice. If we compile this and we run it, you see, you get 2 random values, different values, but it's the same 2 values each time we run this. So that's because how this random function works. So this is because of how the pseudo-random function works. Basically, it is a mathematical algorithm that has a start value, and then each time it's run, it makes another value out of that value. So basically it makes a long list of different random values, and each time you call it, you will get a different value. However, it starts at the same place every time, which means there will be the same random values every time. However, we may give it a so-called seed. That is an initial value that if we give it like the value 1, it will create one string of different values based on that. If we give it 2, it will create other values. We can try that out. The function name is called srand, and you want to call that once every time your program runs, not every time you supply the or you call the rand function. So let's give this the number 1 to srand. We compile and we run our code. Okay, this is the values. It begins by 1804. And if we give it the value 2, you see an entire different line of values, but the same every time we run the code, because the number here is the same. So how do we solve that? Well, we do want to have a value that is different each time we run the code. And there's a lot of different ways to achieve that. My favorite way is a function called getPid. Because every process, like every instance of running this program, will get a different process ID, a PID. So one time when you run it, you might get 150, and the next time 162, and it goes on like that. Most often you don't get the same value twice. So this is perfect in order to seed the pseudo-random function. So let's try to call getPid. I will just try it out like this by printing out the function like this. So you don't necessarily have to have a variable here. You can go directly to the function and print out the return value of that function. And then I will return 0, so we will effectively cut our code here. And I will remove that space because it's not needed and it's ugly. First we'll try to compile this, but we will get an implicit declaration because it doesn't find getPid in the current include files. So we'll go at it the same way we did before. We will do man3 getPid, and this time we won't get a match because this is not a library function, this is a system call. So we will try a 2 here instead, and this time we get a match. So there are 2 includes that we need. I will just copy these, go into Nano and print them out, paste them out here. And I will remove these spaces, and then I will compile the code again and run it. Okay, so this is our process ID, the PID, 31315, and again 31330, 31335. It's different each time, as you can see, which makes it virtually perfect for our seed function. So instead of a 2 right here, we put the getPid function right here. So the same value that we used to print out here will instead feed the srand function. And this way it will produce really random, or more closely real random values each time. Okay, so let's compile this again. And as you can see, we do get different values each time we run the function. We run the program and the function. But these are kind of big numbers. What if we want a number between like 1 and 10? That's why I created this our random function. So the basic is we will give an argument to this one, which we call max, and it's an int. So we can say to our random function that we won't have a bigger number than 10. And how do we calculate that? Well, we can do a so-called modulo operation. It has to do with an integer division. I won't go into the mathematical details of how it works right now, but it works perfectly in order to take a big number and reduce it so it's not bigger than what we want. And it works like this. So we just, after the rand, we will add a % sign and then the 10. or rather the max variable, which is this, and we send our 10 here. So we can send different values. Like, let's say we send a 5 first and then a 10 the second time. But this works like this. If we have a 10, if max equals 10, I will do a comment here so you don't think this is code. So if max is 10, it will create one of these values. So it's 10 different types of numbers, but it's from 0 to 9. But we want from 1 to 10. So how do we do that? Well, let's say this produces the random number 6, and we want it to be between 1 and 10. We could just add 1 to it. That would mean that 0 would create a 1, a 2, and so on and so forth, like this. So basically we'll just do that like this. So we take our maximum value and send that to our random function, so it will be put into this max variable. Then we let our x value be equal to the rand function, which will generate a big random number, and we will modulo down that number to our max value and add 1 to it. So we get a number from 1 to 10 in this case, instead of from 0 to 9. And in this case it will be from 1 to 5 instead of 0 to 4. Okay, let's compile this and run it. 4 and 10, 2 and 7, 4 and 7, 1 and 9. As you can see, the first number always is between 1 and 5, and the last number is between 1 and 10. So our code works perfectly fine as we intended it. Okay, so today we have learned how to use the rand function to generate a big pseudo-random number. We have learned how to use the srand to seed that function so it doesn't produce the same set of random values each time the program is run. We will use the getPID function in order to get the process ID of your instance of your program, in order to feed the srand function with a different value each time your program is being run. This will produce different sets of random values each time. In order to get the size of the random value as we would like, we will create a max value and send as an argument, and we will use the modulo operation in terms of making this number less. And then we'll add 1 to this because of how the modulo function works, and that will produce a random number between 1 and max. And we use that to create our own random function called our random function, which we will call in our code. Quite a lot of different moving parts in today's lesson. I hope you understood most of it, and if you didn't, please rewind back and try to figure out the rest. Thanks for watching, and thanks for today. Okay, welcome back everyone. Today we're going to talk a little bit about the function sleep. So sometimes when you create a program and you want to have like a little break in it, perhaps for a dramatic effect, or if you're creating a game when you throw a dice, for example, and then you want to the user to wait a little bit before the next line of code runs. Then you can use the command sleep, and it's very easy. The function sleep, rather. So let's create a new file called sleep.c, and we begin as usual with our skeleton. Something like this. Okay, so I will make this very easy. I will just print something on the screen. And I will use our f-flush method to print this out without the new line on the end. Then I will use sleep2, which means I will pause the program for 2 seconds. And then finally I will print something else, like an OK. And then we quit. Very easy. If we try to compile this one, as you might have figured out, we will get a warning about an implicit declaration of sleep, because we need an include file in order to use this sleep function. And as we have learned before, we do man space 3 space and the name of the function. And as we can see, we are going to use uni.std.h. So let's edit our code real quick. I just need to open it in the correct editor. uni.std.h, like this. Okay, let's compile it again. No warning this time. It created an output file. And let's run it. Wait while processing. A little pause. And then OK. It works perfectly fine. Just exactly as we intended it to. So today we have learned how to use the sleep function, which freezes the entire runtime of the program for a couple of seconds. You specify how many in this parameter here. And then you need to include the uni.std.h for it to work. Thanks for watching, and thanks for today. Today we're going to code a simple countdown that will put a number on the screen, like a 10, and then it waits for a second, and then it puts out a 9 and an 8 and a 7, and when it goes down to 0, it will stop. Okay, so we will use all the different parts that we have learned this far, and we will create our countdown.c. We begin by our skeleton, the includes, and the comment on the top. I will include uni.std.h because I know that the sleep function is in that one. Okay, so what kind of variables do we need? We need some variable to hold the number that represents the countdown. So let's call that number. And it will be an int because we need a number and we don't need any decimals. And we will set number to 0 from the start. Then we will print, no, we will not set it to 0, let's set it to 5. And then we will print out the value. Just like this. And we will put this inside of a while loop. And I'm gonna use while 1 in this instance. We could use while, because we're gonna reduce a number, so we could use while number is greater than 0. And then it will loop as long as the number isn't 0. But I want to make it another way so we can learn another part of the while function. Okay, so we print out the number, then we are gonna sleep for 1 second to make that kind of dramatic effect. And now we need to decrease the number. So we know that we can set it to 4 like this, but that won't work with a while loop, because then it will be 4 all along. Because we want to use the current value in order to calculate the new value. So it should be 1 less than what it is currently. So the number should be equal to number minus 1. So if the number is 5, like from the beginning, number equals number minus 1 will be 4. If 5 minus 1 equals 4. And then it will be 3 and 2 and 1 and finally 0. So if we just let it be like this, and we'll try out our code. So now we have this kind of dramatic countdown effect, but when it comes to 0 it continues, and now it's using negative numbers, and that's not what we want, right? So we need to check somehow if it's 0 or less. So let's do an if statement. If the number is less than 1, and what do we want to do then? We want to break. The break is a command or a keyword that breaks out of this loop. So when we reach break, we won't go back and run the next round of the loop. We will just jump until after the loop, right here, thus ending the program. So let's try it out now. We got 5, 4, 3, 2, 1, and then it exits. So that is exactly what we want. But I want to show you some ways we can improve our code. If we have an if statement or a while statement and some other commands that uses these brackets, then we know we can have several lines of codes between those brackets, and all these lines will be run if this is true. But if we only have one line of code between a set of these brackets, then we don't need them. Because C will understand that this one line belongs to this if statement, thus rendering those brackets unnecessary. And this is a way to clean up your code. I know that a lot of coders don't want you to do this because they say that it's prone to make mistakes and so on. But I think it's better to learn to avoid these kind of mistakes than writing ugly code just because you're not able to see those mistakes. I think this makes you a better coder. In the long run, anyway. Okay, so that's one thing. And then we have this line. Number equals numbers minus 1. This works perfectly fine, but there are a number of ways we can improve this. Instead of doing this long line, we can do this. Number minus equal sign 1. This means that the number should be reduced by 1. And the same thing works with plus, and I think it works with multiply as well. And this makes your code a little bit more optimized, code-wise said. And in this example here, when we reduce number by 1, because this is a very common task while coding C, there is another way still that you can do, and that is number minus minus. This means exactly the same. This reduces number or any other variable by 1, and you can always do plus plus. So in this way we have made our code a little bit less, but still it will work exactly the same. As you can see, the countdown is still running and exiting. And I want to show you one last thing. In addition to break, there is a command called continue. So continue breaks out of a while loop. Break breaks out of a while loop, but continue moves on to the next round. So if I, for example, would like to skip the 3 in the countdown, I could do if number equals 3, continue. That means if number equals 3, so it prints out 5 and 4, and then on this round it equals 3, and it does continue. Then it won't run any of these lines, it will just jump past them and go to the next round of the while. So the result will be this: 5, 4. Okay, in this case our code breaks because it doesn't reduce. Let's move this up here. No, here. So we need it to reduce the number first and then check. If we don't, then we will get stuck here because the number will always be 3. So because we are starting with a decrease, I will set this to 6 instead of 5, so we still get the same effect. So 5, 4, 2, 1, 0, and then it exits. So it skipped all the code related to the 3. And that might become handy later on. Okay, so that was a lot of different things. First of all, we have learned how to use the break command in order to break out of a while loop or a for loop or any loop. We have learned the continue keyword, which doesn't break out of the loop, but it breaks out of the round and moves on with the next round of the loop. And then we have learned a couple of ways to reduce or add to a number in a variable in different ways. This being number is reduced by 1. Okay, That's all for today. Thanks for watching, and thanks for today. Okay, welcome to today's lesson. Today we are going to do an assignment together. We will do this DICE.GAME assignment. And if you haven't already tried it, I think you should begin by trying it yourself, so you learn a little bit more from it. If you are not able to make it through the assignment, then you could watch this episode and learn how to do it. I think that's a pretty good order of operations. Anyhow, the task is creating a simple dice game where you have $1,000 to begin with, and you bet like $100, and then you throw a dice and you make a guess what it will land on. And if you're correct, then you will triple your bet, and if you're not correct, then you will lose what you have bet. And then you play around a couple of rounds until you are satisfied with your score, and then you quit the game while on top. If you run out of money, then it is game over. Okay, I will jump right into it. I will create a file called dice1.c and enter a little bit of comments in the top and our main include file. I will also add a couple of more, like unstd, so we get the sleep function. And I will also need the stdlib.h, so I can use getPid and the random numbers. Okay, and I will begin by creating a function, actually, because we can't do much with this code unless we have a random function. So I will do something similar to what we did in the random episode. I will create a function called, let's call it random. I'm not sure if that's taken already, but we'll see. And then I will have a max limit. I will create a variable to make this look, well, so you can follow along a little bit easier. And I will call the rand function. I will modulo it to the max and add 1. And then I'll simply return x. So now we have a random function. Let's begin by looking at the assignment. We need to create a variable called balance and assign the value of 1,000. Okay, first we need to create the main function like this. Yeah. Okay. Balance, and it should be an int, so it can hold a number. I will set it to 1,000. And the next step is to ask the user to bet and read that bet into the variable bet. So I'll do these two together. So we need another int, which we'll call bet, and we will print out to the screen, make your bet, and I will flush that in order to make it seen on the screen immediately. Okay, so what do we need? Ask the user to bet and read it to the valuable bet, and we use scan, the SCANF, so we can read that from the keyboard. Then we are done with that. Now, as it says here, code a couple of points of the instructions below, then compile the code and try it in program, then continue on with more coding points. And that's a really good point, because if you make all this at once, even if you're a skilled, experienced programmer, you will most definitely have a lot of errors. But if you make like 3 at a time and save and try it out, then it's much easier to troubleshoot. So that's exactly what we'll do. We'll compile this code. Now we got an error. Yeah, look at this. As I mentioned before, or as I suspected before, previous declaration of random. So some of the keywords in C are already taken by other libraries. So let's call this my. One second. Let's call this my random instead. Now it compiled just fine, and we run it, make your bet, 500, and then it exits, because this is all we have done so far. Okay, what's the next? I'll do these two at once. Ask the user for a guess between 1 and 6, and tell the user to guess 0 in order to quit. Read the guess into the variable guess. Alright, so we need another variable, which is an int. I'll make a little space here so we see that it is a different section. It's completely fine to have line breaks in C. Pretty much everywhere, not exactly everywhere, but close up to it. Okay, ask a user for a guess. Then we will have our printf again. Make your guess. 1, 0, and 0 means quit. So 1 to 6 and 0 means quit. That's possible to understand, right? And we don't need to flush it this time, but we will use SCANF to read it into the guess variable. And then if the guess is 0, then quit the game. So we'll have an if statement. If guess equals 0, then return 0. We need to exit the game. And as you can see, I didn't have any brackets here. And that's because there's only one line of code connected to this if statement, and then you don't need those brackets. Okay, so let's save again and compile and run. Oops, there we go. Make your bet 500, make your guess 5, and then it's done. Now we should pause the game for 2 seconds, generate a random number. Because we have already prepared the random function, and before I forget, we should add this srand thing in here as well, so we don't get the same numbers all the time. And this should be on top of your code inside your main. You can have your variable declarations before it, but then it should come, and you should only call it once per program run. Okay, pause the game. Then we will do sleep2 and generate a random number, which we will store in a variable called dice. So we need an additional int variable, which we'll call dice. And dice will be equal to my random. That's the function we wrote. And we want the 6 to be the highest possible number. And let's print that one out on the screen so we can see what's happening a little bit. And let's try it out. 500, 5. It pauses for 2 seconds, and then it prints out what the dice landed on. Okay, so what's next? Check if the guess matches the dice. So it's another if statement. If guess, it's says it like this: check if the guess matches the dice. If they don't, subtract the bet from the balance. So in this case, it's easier to check if it's not equal to. If guess is not equal to dice, then we should lose money, right? And we should subtract the bet from the balance. And how do we do that? We do balance equals balance minus the bet. Because if we have 1,000 and we have bet 100 and lose, then it should be 900, right? 1,000 minus 100. We can also use the other method we discussed in an earlier class. Balance minus equals to bet. That's the same. It will reduce this variable by this amount. And I will keep these brackets here because I will add a couple of texts later on. Okay, so if this isn't true, if we actually won, and that will be our else statement, and what will happen if we win? If they do match, multiply the bet by 3 and add that to the balance. Okay, so we will take this in 2 steps. We will begin by multiplying the bet by 3. So bet equals bet times 3. And now we can try if this works, that I talked about last time, and I said it probably works. So this should be the same as bet equals bet times 3. So if we did bet $100, then our bet should be 300 after this. And now we only need to plus that to the balance. So these 2 lines should add those $300 to our balance. Now we should check if the balance is 0 and then quit the game. So if balance equals 0, I will print out game over. And exit the game. And now it's time to see what we have done this far. So make your bet like 100, make your guess 2, and I bet 2. I don't really see what's happening right now because we don't have any texts like saying how much our balance is. So let's add that. Print f balance. We put a $sign and then the amount. %d for an int, the value of balance. And where are we? If the balance is 0, quit the game. We have done that. If the balance is positive, loop the game to be able to play more rounds. Yeah, we should be able to play more than 1 round, which means we would loop almost our entire code. So if balance is 0, then it quits, which means we don't need another else statement here or another if statement. We can just put our code here because it quits if this is true. Okay, and we should loop this code. So let's start with where in the code we should add our loop. How much of this code do we want to loop? Variable declarations, we only do that once. The srand, we should only do once. What about balance equals 1000? If we loop that every time, the balance will be reset and you can't win or lose any money, so not that. Make your bet. Yes, we should be able to make a bet every time. So right between here is where our loop should begin. So we can do a while one loop to loop everything. And I will jump out one step everywhere, which will make this code much easier to troubleshoot. It's a little bit tedious to do this, but it will be worth it later on. There we go. And there is where our loop should end. So all of this code will be, all the way here, will be looped all the time until we run out of money or quit the game. And now we should add a couple of texts. Throwing dice, congratulations, you lost, your balance is, etc. This one we have already done. We could better this a little bit. Dice results. And throwing the dice, let's put that before the sleep. Throwing the dice. Like this. And some congratulations. You won. Congratulations. And if we lost, let's just print. Sorry, you lost. Something like that. And your balance is already done. Throwing the dice, congratulations. Think that should be it. The only thing we have left is add some comments to your code. Okay, that's always good to do, because even if you understand all of this code, and you probably will understand it even a week from now, but if you go back 2 years from now, would you understand every bit of this code? Probably not. So comments is for your own good. This will create a random number between 1 and max. And we could add seeding the number generator, the random number generator, to be more specific. This code is probably quite self-explanatory. Maybe we could add something here. User presses 0 in order to quit. Something like that. Okay, let's save. And we compile and we run. Make your bet. 50 and 2. Throwing the dice, and the dice results 4. Sorry you lost, and the balance is 950. It works just fine when we lose. And we probably need to play a couple of rounds before we encounter a win. If we want to make this a little bit faster when we debug the code, we could disable the sleep directive. Ah, here we go. I bet 60. I had 800, I bet 60. And I guessed the number 6, and the dice landed on the number 6. And I won, congratulations, and now I have 980. And 60 times 3 is 180, which is correct. Works. Okay, so if I just make any bet and then I choose 0, the game ends. What if I use up all my money? I bet 1,000 on 6. Okay, I won. I bet 4,000 on 2. There we go. It landed on 4. I lost all my $4,000. Sorry, you lost. Game over. So our code is complete. So what have we learned today? We have learned to use all of the different parts of this beginner's course. And we have learned something else as well. Let's go into the code one last time. We do this and this and this. I think we have learned each and every different part of this code before. So what we have learned is how you use it all to make a big assignment. Now I hope you will try it one more time for yourself, the assignment that is, and see if you can't create this game on your own. And this concludes the current beginner's course. Perhaps I will add more lectures to the future, and I will start with the advanced course. You are welcome to join me. Thanks for today, and thanks for watching. Welcome everyone to today's lesson. Today we're going to talk a little bit about structures. And what is a structure? Well, you can create your own kinds of variables in the C language. And you do that by creating a structure. So you combine several different variables into a new kind of variable, like a composite variable. So if we create a file called STRUCT.c, and we only need the standard IO library. And where do we define our structures? Well, we define them outside of main. So we create our variables based on the structure inside of the functions like main, but we create the actual structure outside of the functions. So we can think about, like, when you're building a house, first you need the blueprint, and the structure is the blueprint. Then you use the blueprint in order to create the house, or several houses that you create from that blueprint. And the same is true about structures. You create the structure, which is the blueprint, and then you use that to create your different variables based on it. So let's say we will create a very tiny little database containing the title and the last name and the age of one person. You can easily make this about several persons and increase the database, but in this example we will just do one. So we'll create a structure called person, and that structure will have 3 different variables inside of it. The first will be the title, and we only need 8 characters for that. The second will be last name, and we'll put in 32. And if you have ever wondered why I use 32 and 8 instead of like 10 and 30, I could use 10 and 30, but the way the memory works is that you assign or you allocate parts of the memory in blocks of 8. If you have an older 32-bit processor, it might be in blocks of 4, but most probably it will be in blocks of 8. That means if I were to select 10 instead of 8, it would actually allocate 16 bytes of memory. And that would probably work just as fine, but this makes it a little bit more controlled and optimized. And finally, we will have an int containing the age. And here is a thing to notice. When you close this structure's brackets, you end with a bracket and a semicolon. Usually you have either a semicolon or a bracket, but with structures you end with both. And that's basically because you can put names of variables here, and then you create a structure or a blueprint at the same time as the building or the variable. But for now, use both, just a bracket and a semicolon. Then we create our main function, and we will create our variable. So we type in struct and the name of the struct, and then the name of the variable we want to create. So I will create a line in this database for myself. So I will call this Birch. And then we will need to fill this structure with data, and I'll be using the string copy function to copy information into it. And you reference it by typing in the name of the variable, dot, and then the sub variable that the structure contains. So birch.title is referring to the title variable of the structure called birch, which is on this blueprint. And I will copy my title, and I'll put 7 here. The third argument to string copy is the maximum number of characters that we will use to fill this string, and I always take the maximum minus 7, so I will not make a mistake. And I'll copy into birch.last name my name, and I'll put 31 here. And finally I'll just type birch.age equals 38, and then I will print this out. So title, first name of the age, and I'll put these on different lines so we don't create a very long line, and it'll be easier to read. So the first is birch.title, and then birch.last name, and finally birch.age. and then we'll exit accordingly. So to summarize this, we create our structure, that is the blueprint. Then inside the function, we reference the structure when we create a variable based on that structure. So we create an instance of this. We reference that instance by the variable name dot and then the actual sub-variable of that structure. So this can be used like any string variable. So we copy the data using string copy, and we use this format when we put an int into it. So variable dot sub-variable. And then we reference the same way when we print it out. And if we compile this one, we get an warning. Yes, we need to include an additional header for that string copy command. So include string.h. There we go. Dr. Birch of the age 31. So today we have learned how to create our own structure. We have learned how to create a variable or an instance of that structure, how to fill that structure with data, and how to reference that data when we print it on the screen. Thanks for watching, and thanks for today. Welcome back everyone, and welcome to today's lesson. Today we're going to talk a bit about the keyword switch. So switch is basically like an if-then statement, but it takes a single value as input and it makes decisions based on that. So it's a little bit easier if we have an example. Let's create switch.c, and this will not be a very useful program, but it'll demonstrate what we are talking about. So I will create a value called x, and I'll ask the user to choose between 1 apples, 2 pears, or 3 bananas. I'll use SCANF in order to read that value. And first we'll do it with if statements. So if x equals 1, print apples. Else if x equals 2, print pears. Third else if x equals 3, then we will print bananas. And at the end we'll have an else statement printing something else. Very simple code. Let's compile that code. And we'll try 1 apples, 2 pears, 3 bananas, 4 something else. Very simple. This is a good example where we can use the switch statement instead. It makes it a little bit easier to read the code and perhaps a little bit easier to code it as well. Let's see. We do switch and then we supply with the input. It needs to be an int or a char, something that is very specific, not like a pointer or a, well, it could be a pointer pointing to an int, but not like a string or anything. So we'll switch based on x, and then we create something called a label, and the label is 1. I usually do something like this as well, so it makes it a little bit easier to understand. So in case of 1, we want to print apples. And then we'll break. If we don't put in the break here at the end of each label, it will continue. So I'll show you what I mean. Let's do this one as we should. Pairs F pairs, and then I will forget to put in the break here. I'll go right on to the bananas. And at the end we can put default, not case default, just default. And we'll print something else. So doing like this, it makes up these nifty blocks of code for every different value. So it's a little bit easier to read and it looks better, I think. Let's recompile this one and let's run it. Okay, so if you type in 1, we get apples. If we type in 2, we get pears, bananas, and something else. If we type in 3 for bananas, we get bananas and something else. And if 4, we get just something else. So something is wrong with our code. And as you probably have figured out, it's because of this break. So without the break, it switch jumps to case 2, runs this code, and then continues on to case 3 and the default. So we need to end our blocks of code with break. The default one, or the one on the bottom, there it's not necessary, but all the other ones end with a break. Now it works exactly as intended. So what have we learned today? We have learned that in order to make like a menu or something where we have an input value and we want to do several different options based on that single value, then instead of nested if statements or if else, etc., we can just switch the x. Then we do these blocks of code connecting to a label. This is the label. So switch checks the value of this. If it's 1, it jumps here and runs this code, and then breaks, goes here, and same. If switch is 2, or if x is 2, it jumps to this part, or if it's 3, it does this part, and default, it will do this. That's all for today, guys. Thanks for watching and thanks for today. Welcome everyone to today's lecture. Today we're going to talk about pointers. So pointers is something that a lot of people find difficult, but it's really quite easy to do, at least the more easy operations regarding pointers. So a pointer is a variable in C that doesn't contain any information on its own. You don't store any data inside of it. Instead, you use that pointer to point to another variable or to another part of the memory. So think about it like a shortcut in Windows. You create a shortcut of the real file, and when you access the shortcut, you access the file that it's pointing to, but the actual shortcut doesn't contain any information. So let's create pointer.c, and we will begin as usual with our skeleton. And I'm going to start by creating a regular string that we have used before. And I will copy some information to that string. Let's do I like apples. And string copy is a function included in the string.h library, which takes 3 arguments. The first is the target variable where we want to copy the information. The second is a variable or a string that we want to copy to this destination. And the third is the maximum number of bytes that we're going to copy. And I usually use the size of the string -1. And because of that, we don't risk overflowing that buffer. Okay, so far nothing advanced. Then we will create a pointer called p. So when you create a pointer, you define the type of variable as usual and the name as usual, but you put a star in front of its name. So this means that this is a char pointer, a pointer that can point to any other char. So in order to point this one at something, I just type p equals str. So now p is pointing towards this string. And if I do a printf statement and I give p as the argument, so we want to print out p. Then it prints out the entire string, I like apples. Then we can manipulate this at different ways. We can, for example, do p equals p plus 1. What this means is p will no longer point to the first character of this string. It will point here. So now the I disappeared. There's just a space and like apples, because we will point to the next char in memory, which is this one. We can also just do p++. That has the same effect. So pointers can be used for like enumerating
a string. Like if you want to code something that goes through all the different characters in this string and like make it from lowercase to uppercase or something like that, we can use pointers this way. So we increase it every time we have changed it to uppercase. Another way of accessing this one is if we reset this code so it points to the beginning of the string, we can also tell C to access not the whole string but exactly this part of it. So let's change this to a C, and then we put a star in front of the variable name. So what does this star mean? Well, this means that we shouldn't access the pointer. We should access exactly what the pointer is pointing to, and that is the first character of the string. So now it just prints out an I. So what have we learned today? We have learned how to copy a string using string copy. We have learned how to create a pointer and point that to another variable. We have learned how to manipulate that pointer, like increasing it, making it jump forward to the next character in the string. And finally, we have learned how to use the star in order to access the exact thing that it's pointing to. Thanks for watching, and thanks for today. Welcome everyone, welcome to today's lesson. Today we're going to talk a little bit about for loops. So let us create a file named for.c. This far we have only talked about one kind of loops, and that is the while loops. So in the while loops we can do like this, and it will loop any code that we put inside of these brackets. This code will be looped indefinitely, or until we issue the break command. And we can also do something like if, as long as x is more than 5, or something like this, and then we can have a countdown down to x equals 5. So that's the two ways we can use while loops, and we have talked about these already. Today we're going to talk about for loops. So for loops are based on 3 different fields. So let's call them before each cycle and no, I mean condition, and here is each cycle. We can specify it by end of each cycle. So we issue 3 commands when we do a for loop. This command will be run before the loop starts, and it's only run once. This is the condition. As long as this condition is true, we will keep on looping, same as this part of the while loop. And this part is code that is being run once every time it cycles. So let's say we have some code here. So this would be some kind of code that we want to loop.
So this command is run before. So we can type in before here. And the condition, well, that's checked every cycle. And it checks if the condition is true, and if so, it keeps on looping. If it's false, we break out of the loop. And this part, this is put right here. So before it goes on to the next cycle, it runs this command. And this combination of the three different parts is often used by different kinds of enumerations. Because if we use the before part to set like x equals 0, and then we have a condition like loop as long as x is less than 10. And then at the end of each cycle, we want to increase x by 1. So in that way, we can easily do something with number 0 and do something with number 1 and 2 and 3. And that is a very common task when coding C. So that's why the for loop exists in addition to the there we go. In addition to the while loops. So, what are we going to be coding today? We're going to code a simple tool. The user will be asked to input a number between 1 and 12. Then we are going to show the multiplication table for that number. So let's jump right into main, and we will create our x variable and our table variable. So the user will be prompted, select multiplication table, and then f, and I will define f as f/stdout, so we can easily use lines that doesn't end in a line break. And then we will read a number into our table, and we're gonna use a new command called assert. I'm gonna describe it in a little while, but we are gonna assert that x is less than 13. No, not x. The multiplication table should be less than 13, and it should be more than 0. And in order to use the assert function, we need assert.h. So basically what assert does is it validates this condition, and if this condition is true, it does nothing, just moves on. But if this condition is not true, it aborts and exits the entire program. So this is a easy way to do some fault handling in order to check for a couple of things that is necessary for your program to work. So you will most probably don't use this in a production environment, but for testing and educational tools like this one, it's kind of perfect. Okay, so what are we going to do now? We're going to do our for loop, and we begin by setting x to 1. That is the first. No, let's set it to 0. So we're going to do, if we select the fifth multiplication table, we're going to do 5 times 0, 5 times 1, 5 times 2, all the way up to 5 times 12. And this is a perfect example for the for loop. So we set the x to 0. We are going to loop as long as x is less than 13. That means we're going to loop from 0 all the way to 12. And we're going to increase x with 1 every cycle. And what are we going to do with this x variable at each cycle? We're going to call our function, and let's name that multi, and we'll just pass on the x variable and return 0. And no, we needed one more. We'll give it the table as well. Okay, so let's create our multi function. The first argument is the table, let's call it t, and the second is the value, let's call it v. And we will have a result variable, and we set result equal t times v, and we're also going to print it out on the screen in this format. The table times the value equals the result, like this. And the first variable is the table, the second is the value, and the third is the result, like this. And then we return. So quite easy code. 2 variables, one for the x and one for the table. We read the table from the user. We assert that it is between 1 and 12. And then we do a for loop that loops 13 times, with x being from 0 all the way to 12. So x less than 13 means 12. And we'll increase x by 1 each run. And we'll pass those two values to the multi function. And the multi functions multiplies them together and prints out the results. Let's see if this works. It compiled. That's always a good sign. And let's begin by selecting a bad value, 0 for example. Then we can see that the assertion failed and the program is aborted. Same if we type in 13. But if we type in 5, then we'll see the whole fifth multiplication table. And same with 11, same with 3, and so on. So this code works. And what have we learned today? Well, we have learned how to use a definition in order to make an alias for the flush function. It's also called a macro. We have learned how to use the assert directive in order to check that several conditions are met before continuing. We have learned the for loop, which starts with a begin value, which loops as long as this condition is true, and it runs this command once every cycle. And then we just print the results to the screen. Thanks for watching, and thanks for today. Welcome back everyone, and welcome to today's course. Today we're going to talk a little bit about the ampersand, the and sign. So when you are calling a function and specifying an argument to that function, then you most often send the actual values of the variables that you are submitting to that function. But you can also send the address of that variable. And that's what we're going to talk about today. I will create a file called ampersand.c. And from the beginning it will be a very simple code. It will use a function called addition, which will take two values, int a and int b, add them together and return the value. Very simple, just like we've done before. To make it easier to see every step, I will create a result variable, which will contain the result of the operation. So a plus b. And then we just return the result like this. Very simple. And then I will create a main file, a main function, where I will create two additional variables, x and y. I will hard code the x variable to 5 and the y variable to 15. I will also create an answer variable like this. And just like we have done before, I will call our addition function, supplying x and y as arguments, and putting the result in the answer variable. Finally, I will print that value to the screen and exit the program. We'll compile this. Oh, it should be dash O, not dash C. And then we run it. And as we suspected, the result is 20. Nothing new under the sun. But another way of doing the same thing is using the ampersand. So instead of returning the return value, the result, we will supply the address of our answer variable, and we'll put the result into that variable directly from the other function. Let me show you what I mean. We will create a third argument to this one, which we will call, what should we call that? Target. And as you can see, I make this a pointer. Then instead of returning the value like this, I will send the address of the answer variable. So as a third argument, I will send the answer with an ampersand. And instead of returning, we can even make this a void function. Void means that it doesn't return any value. So it'll be just like this. We could omit the return keyword completely, but I think it makes better code if you put it there, so it makes sense that the function is over. Okay, so we can delete this result variable, and instead we will set the target to a plus b, like this. Notice the star here. If I just did like this, we would try to change this pointer's variable, pointing this pointer to something else. If we put a star here, then we mean we will change what's inside of this, i.e. the address to this variable. Let's see if it works. Okay, it's for sure didn't like that one. Passing, oh, I put it on the wrong order, didn't I? Yeah, I put x, y, answer. Here I have answer x, y. So let's just spin these around a little bit. So we'll put the int target at the end instead. And we'll try again. This time it compiled. Let's see if it gives us the correct value. It does. So today we have learned how to use the ampersand to send the address of a variable to our function. We have learned that we need to make this a pointer, and in order to change that variable, we need to put the star in front of the variable. And the star means that we shouldn't change this variable, we should change whatever's inside of this variable. And that's the address of answer. So we're changing this, and then we'll print it out on the screen. So this is just another way of passing values and changing stuff in a function and in another function. And I hope this must come to use for you. Thanks for watching, and thanks for today. Welcome everybody to today's class. Today we're gonna talk a little bit about dynamic memory. So dynamic memory is best illustrated by an example. I will create a file called dynamic1.c, and I will begin with the header and just one include file, and then our main function. Okay, so if I would like to create a simple program with one variable to store a name that we read from the user just using SCANF, then I would do something like this. Create a variable of the type char with a size of 32, for example. I would print out something like, what is your name? And then use the SCANF function to read that from the user, just like we did previously in another example. And finally, I will use that name in order to greet the user, like this. And then we quit. So if we run this code, and I will put in my last name, and there I have the result. Okay, nothing new here. But what if we don't know that these 32 bytes would be enough? Perhaps we are reading in a couple of numbers from the user. So what if the program asks the user, how many numbers would you like to enter? And then the program will loop and ask for numbers until we're done. But then we would have to allocate a whole lot of memory because we don't know beforehand how many bytes of memory that's needed. That's one example of why we should use dynamic memory allocation instead of static. So this thing we have done here is an example of static memory allocation. We're specifically telling the compiler that we need 32 bytes of memory. But instead of doing it like this, we can create a pointer out of this variable. And then we use a function called MALLOC in order to allocate this memory. And it's quite easy to use. You just point the pointer towards the malloc function, and then you specify one argument, and that's the number of bytes that you want to allocate. Then it will dynamically allocate 32 bytes of memory, and then this works as before, but on the end we free this memory allocation. It's not always necessary to do this, especially not at the end of the program, because this will be freed when the program exits. But it's a good habit to always free the memory allocation as soon as you're done with it. Because if you don't, then after a while, if you have a big project, there will be a lot of memory allocated that you don't need, and it will use more memory than what's actually needed. Alright, let's try this out. Okay, we get a lot of these implicit declarations, malloc and free. And it even gives us an example of or how to fix this. It says we should include this standard library.h, and if we do man to malloc, I mean man3 malloc, then we can see here that it's in the standard lib library. So we go back to our code and add that include file. And this time it crashes. Why does it crash? And that's because when we are using pointers and dynamic memory allocations, we can't use this form of scanf. Because what this actually means, this ampersand here in front of the variable name, is that we are not sending in the value of this variable, we are sending in its address, its memory address. And that basically works just fine when using regular variables, but when using pointers like this, a pointer that points to a specific memory allocation, then we get the address of this pointer instead. And we do want to get the value because the value is this memory allocation, and that's where we want to scan it to. So remember this, when using pointers and when using dynamic memory allocations and SCANF, remove the ampersand. Let's try it again. And this time it works. So this is a very basic example of dynamic memory allocation. We will get into a more real-world-ish example later on. But hopefully you have learned the basics of it, that you create a pointer, you point that pointer towards MALLOC function, and the only argument is how many bytes of memory do you need. Then MALLOC will create this allocation, so it will create a space of memory, and in here you can put whatever you like. Don't forget to free it up at the end of it. And when using SCANF together with a pointer and a dynamically allocated memory, remove the ampersand in front of the variable. Okay, thanks for watching and thanks for today. Welcome back everyone. Today we are going to talk a little bit about sockets. So a socket is a IP connection usually. So you connect to a server somewhere on the internet or in the local network and you send data. In our case we're going to do a TCP connection on port 80. And 80 is the HTTP protocol, which is used for clear text communication on the web. So we're going to connect to a web server. It'll be something like this. And we're going to send an HTTP head command, which basically checks the headers of the web server. Okay, this was a bad example. I can't access this from inside the network. Let's do Google. And we'll send the head command. And this is what we get back. So usually when you send a HTTP request, you get the headers and then you get the data. But if you use the head command instead of the usual get command, you just get the headers. So it's a good way to test out if it works. And in this example, we're not going to use any DNS. So we're not going to resolve this domain address to an IP address. We are just going to supply the program with a hard-coded IP address. And we can find that IP address by doing the host command or the NSLOOKUP command, or even just ping it. And then we'll see the IP address here, and here, and here. And we're not going to use IP version 6, we're going to use IP version 4. Okay, so let's create a file. I'll code it in VI today. and we will call it sockets.c. As usual, we begin with a header and the header files. I will only include the standard IO for now. We're gonna need quite a lot of includes to do this, but I will do it in the way that I begin with this one, try to compile my code, check the errors, and see if there's anything I need to add. And for some of the functions I'm gonna check the man pages as well. Okay, so let's do a definition constant with the IP address. And we'll use, okay, I'll just issue the command from VI like this. Let's try it again. Host and www.google.sc like this. So if you don't know this, you can type in the colon and an exclamation point, and then you can run any Linux command and it will show the output on the bottom of the screen. Quite nifty in cases like this. And we'll do a constant for the port as well, 80. Like this. And we will do it easy for us by putting everything inside of the main function. Okay, so what do we need in order to do this? We begin with a socket return value. So this is like a file descriptor for the socket, and it's an int. We will also need a structural type called sock address in sock. This is where we put our IP address and so forth. So let's begin by initializing the socket. So we make a call for socket and we tell it that it should be an internet connection and a stream that is used for TCP connections, and then I believe the last argument is just a 0 if I remember correctly. Let's see if we get it right. We can take this at the same time. Okay, so domain type protocol, and these are the domain AF internet, IPv4 internet protocols. Okay, so that's right. And then we have the type sock stream, provides sequenced reliable two-way connection based byte stream. So that's a TCP connection. And then what was the last one? Protocol. Let's see what it says. Protocol. Here we are. The protocol specifies a particular protocol to be used with certain. Normally only a single protocol exists to support a particular socket type within a given product family, in which case protocol can be specified as 0. Yes, I remember correctly. Haven't done this for a couple of years, but I still got it. Alright, so I forgot to check the return value. We want to maintain good error handling. Okay, so where do we have it? return value. On success, a file descriptor, on error, -1. So if s is less than 0, we will print out, socket error, and returns -1. -1 is a standard error code for Linux programs. Basically, it means every error. Okay, so now we have a socket initialized. Now we need to fill our sock address in structure. So we're gonna do the sock address, syn address, source address. This is the IP address of the target. And we need to call the inet address function and provide our IP address. So basically this function takes the IP address from this format and makes a big number out of it. And while we're at it, let's check if we need any includes for this one. We'll just grab those. And I forgot to do the same with the sockets function. We probably take a bit too many includes when we do this way, but that's okay. Okay, socket we did twice. Types age in. Okay, this looks right. And 1, 2, 3, 4, 5, 6, 7. 7x. 7x, 7x. And we don't need this ugly comment over here. Okay, so now we have the destination address. We also need to put in the port. I think it's like this. And the port does also need to be formatted. I believe it changes it from big endian to low endian or something like this. It's the h-ton-s function. We'll just put it in our constant port over there and see if we need any includes for this one. Only one. Let's see what it does. h-ton-s. The h-ton-s function converts the unsigned short integer host from host byte order to network byte order. So basically that's probably if the number is like this in hex, we just change it around like this. Probably it won't do much because the port is so low, but it might. Okay, I think there is one more option we need to do. We have the IP, we have the port. I think we need to put in the syn family as well, if I remember correctly. Do we need to put in the other one as well? Man3, no, man2 sockets, domain type protocol. we can do like this. When you're not sure of the format of a particular structure type, you could just take this one and then you grep for it with the -R, and then you search in the user include directory. We will probably get quite many, but let's see. No, nothing. Sock address in. Grep -R sock. What's his name? Sock address in. And this time we search this directory. What if we just grep for sock address? Never mind. Let's just see if it works without any additional things. The next step is to connect to the host, and then we will use the connect system call. So we do connect, and then we do we will put our sock here, but we need to typecast it to a sock address. And then we'll put the address of that. And we need the size of that structure. And there's one more argument as well. Yeah, we need to connect it to our socket. This is the right one, I think. Like this. And let's check the return value. And the header files. We do have both of these anyway. So first we have the socket file descriptor, then we have the socket address, and then we have this length. So we did it right. What about the return values then? 0 is returned if it works. Okay. So if this is not equal to 0, then we will do a printf, and this time connect error, and we'll close the socket and return -1. And we'll put some temporary stuff here and see how it looks this far. So if we just run this code, sockets.c, okay, unknown type, sock address in. So where is that structure? it shouldn't be sock dash address in. It should be like this. So that's why we didn't find anything when we search for it. So let's do this search again then. Grep r sock address in. Here we go. Okay. So where is the actual struct? Is this perhaps? Resolve.h. We'll search for that. No, it's just a part of this. Struct address in and this address. No, that's not right. Let's keep on looking. Okay, so we probably had it right from the beginning, but I thought it was a type-def structure. We need to actually specify this struct. Okay, now we're a little bit closer. What does it say? Sock address is undeclared. Okay, that's probably because of that dash again. Like this. No, it's still like that. Perhaps we don't need to typecast it. Let's see what happens if we don't. Yeah, there it is again. So instead of sock address, we'll just do sock address in, like this. And once again I forget the struct. Okay, it says an incomplete pointer set. Let's check the connect manual again. Const struct sock address. So it should be a struct sock address. We tried all possible combinations but that, I think. Okay, so struct sock address and sock, compile. Okay, now we only have one left, and that's close. Where might close be? UniSTD, okay. And voila, it compiled. Okay, let's see if it runs without crashing or giving us errors. No errors. That's great. Okay, so one can assume that we managed to connect to that server. So now we just want to write something and read some bytes from it. So I will just do this. We need a buffer in order to read, and we just need some static data. So let's say data is get no, not get head HTTP, and then we need, I think this ought to do it. So first we write that data, And I think we should be able to just use the right syscall. And we write it to our socket. We write it to our socket file descriptor, and we specify the data and the length of the data, like this. And then we just do a read from the socket to the buffer, and we read a maximum of 511. Then we close socket, we print, we'll do like this, new line, and then we print the data on the screen. And I'll just clean this up a little bit. And we return 0. Okay, so let's compile this one. Okay, we need a couple of includes for these functions as well. So we'll include stdlib.h, and I will also throw in string.h. Like this. Okay, let's try it out. Okay, we did get some data, it seems, but no, not really. Let's do it. Maybe the data needs to have these Windows kind of style new lines. Like this, rn, rn. And we're sending head. I think it looks right. Let's memset our buffer as well, so it's clean and nice. And we'll try again. Let's do an strace. So we start the socket, we do the connect, we write the data, but we don't really get anything back. We get a 0. Return value 0 indicates end of file. So it looks like it's closing down our connection. Let's try something other than Google. Perhaps they firewalled us out or anything. Let's try yahoo.com. And we'll just grab the first one here. And we'll put it right here. Search yahoo.com. We'll recompile and we'll run it again. This time it works. Great. So we read this data from the server. Okay, so what have we learned today? We have learned what kind of variables to use when creating a socket. We have learned how to use the socket command to initialize the socket, and how to fill this socket address in structure with the IP filtered through the inet address function, the port filtered through the hton_s function, and the syn family. Then we execute connect, which is binding everything together. The socket file descriptor, that is this int. And then we have the socket address in structure, typecast, and we send the address of that and its size. And if all this succeeds, then we use the regular write command to write stuff and the read command to read stuff, and then we close it. Thanks for watching, and thanks for today. Okay, welcome everybody, and welcome to today's class. Today we're gonna code our very own TCP server. We're gonna listen for a TCP port, and when we get a connection, we will send a predefined message, and we will close down the program. So very simple server to demonstrate how it's done. And then we're gonna build on that code later on. Okay, so last time we coded a file called sockets.c. This one. This did the opposite of what we're gonna do today. This is a TCP client that connects to, in this case, www.yahoo.com on port 80. So it's the HTTP port. It connects and sends the head command, which checks the headers of the server. And then it just prints them out on the screen. So what we're going to do today is quite similar, only the opposite. We're going to be listening for a port instead. And then we are going to connect to that and see what happens. Okay, so in order to make an outgoing connection, we first initialize the socket, then we fill the structure with the IP address, port, and address family. We use the connect in order to connect to the server, and then write and read to read and write to the server, and then we close down the connection. We're going to do quite similar things today. We will initialize our socket the same way, and we will use the same structure for the server. But instead of the inet address function, we're just going to use a 0. That means we're listening for all the IP addresses on all the IP addresses on the server. We're going to use the same way of defining the port and the AF family. But instead of connect, we're going to use a very similar function, taking the same arguments, producing the same result, but it's called bind instead. And that basically binds this socket or this structure with this initialized socket. Then we're going to use the listen function to establish the listening on a TCP port. And finally we're going to use the accept function, which basically waits for an incoming connection and creates a new socket for that one. Okay, I'm gonna copy the include files from our old project to speed things up a little bit, and then I will create a file called serve.c. So we'll begin with our header and all the age files, and we'll do everything inside of main just to try this out. Last time we used one socket file descriptor. Today we're going to use one for the server and one for the client. We also need a socklen t variable, which is basically an unassigned integer. and we'll call this one address length. This is necessary for the accept function. And then we're going to create two sock address in structures, one for the server and one for the client. And I'll start by erasing these structures using the mem set with a 0. We could use the b0 function, but it basically does the same, so it doesn't matter which you choose. So we'll erase the serve and the client, and probably this is not necessary, but it doesn't hurt anything, and sometimes it's good. Alright, so now it's clean. We will initialize our server socket the same way as we did before. So the AF inet family and the sock stream domain and a 0 for the third argument. And if socket is less than 0, we will print an error message telling us that socket failed, and we'll return -1. Okay, so now we have our socket initialized. Now we're gonna fill our serve structure. And we begin with our SYN family, which is AF inet for internet. And we'll use serve SYN address S address. And we'll just set a 0 there for all IP addresses. We could also use in address any, which is a constant that does the same. Okay, and then we'll set the port. Let's create a couple of constant definitions, or at least one for the port, and I'm going to use 8181. And the SYN port will be sent to the HTON S to produce the right kind of ending a number for the port. Okay, so that's the server structure. Now we're gonna bind it together with the socket. So we'll call bind and we'll send the socket as well as the serve structure, and we need to typecast this the same way we did struct sock address, the same way we did with the connect function last time. And we'll send the size of serve. Okay, so bind works that way that it returns 0 if it works. So if it's not 0, we will print an error message telling us that bind failed. And then we will return -1. Okay, so that's socket and bind. The next step is listen. And listen takes 2 arguments. One is the socket, S, and one is the queue. So the queue is basically how many queued network connections are we going to keep before dropping them. So if we set a 5 here, for example, then we can have 5 simultaneous connections. And for the sake of argument, let's put 5 in there. And I think listen works the same way, that if it, let's double check the return value. So yes, it's a 0 if it works. So we can do the same way that we did with the bind. And we'll print out that bind failed. No, listen. Listen failed. And we'll return -1. So socket, then bind, then listen. Now we are listening to the port, and it'll show up in netstat, for example, that we're listening on 0000:8181. And now we'll just accept the connection. And accept takes 3 arguments. The first is the server socket. The second is the server structure. Same syntax as the bind directive. And the third is the address to an int. That's basically my address length. Let me just set this to 0 from the start. It doesn't really matter. So we'll send the address to that one. And why do we do that? Well, that's because accept will write the length of the address, how many bytes the address is, to this int variable. So we'll just put it right here, like so. Don't think we need to typecast anything. We'll see what it says. And we need to take care of the return value, because the return value of accept is a new socket file descriptor connecting the client. So if we pass the C to read, we will be reading from the client. And we will check if C is less than 0, then accept failed. And we'll return -1. We will also close the socket. It doesn't really matter, but it's good to code it like that. If you open something, don't matter if it's a socket file descriptor or a regular file descriptor. Remember to always close it if you don't need it. Same with dynamic memory allocations. Always free the memory allocations. So we'll do the same here. We'll close S and return -1. Okay, so if it didn't return a value less than 0, it means that it works. So let's print something. Client connected. We can also do a similar thing for or after the listen function. So listening on 0000:%d, and we pass in the port. Let's use a constant over here as well, like so. And what are we going to do when the client has connected? We're going to send some predefined data. I will create a buffer we're not going to read any real information here, but we need to take care of the input somehow. And we'll create a char pointer with statically defined data. Okay, so let's begin by reading from the client. So we'll just do read and see buff 511. Then we will prepare our data, and let's pretend this is a web server. I will not follow the protocol at this point, but I'll just return something like HTTP version 1.0, something like that. And we will write to see the data with the string length of the data. Then we'll close the client connection and the server connection and return 0. And that should be it. Let's go look through our code. So we begin by zeroing the variables. We initialize the server socket. We prepare our structure. And then we will use a bind to bind the structure together with the socket file descriptor. After that, we pass on the listening function in order to start listening for our port. Then we'll do the accept. At this point, the accept function will be waiting. It can wait an hour if so. It will be waiting for a connection to connect, or a client to connect. And as soon as it connects, the accept function returns a new socket file descriptor for the client. Then we'll just use that client file descriptor to read and to write and to close. And that should be it. Let's save this one and see if we invented any bugs. No, it compiled right from the start. Okay, so let's start up the server like this. No error message. Let's do a netstat -an grep listen. And as we can see, we are listening for port 8181. And then I will just do a telnet connection to localhost. And I use this env stuff in order to clean the environment variables, because telnet has a tendency to send these environment variables through the connection. And I don't want any additional data sent to the server. So 8181, and we will send something like head, pretending to be a web client. And as you can see, we did get the HTTPD version 1.0 back. So our program works. What have we learned today? We have learned to create a TCP server by creating a socket file descriptor from the socket function, preparing the structure, binding them together, listening for the port, and using the accept function to accept the client. And then just use the regular read and write functions, or system calls rather, to send and receive data. and then we close the connection. We will be adding on to this client server, and we will be creating our own sample web server step by step. And this was the first step in order to try out how to create a TCP server in Linux C. Thanks for watching, and thanks for today.
In today's episode, we'll be coding a Wordle game. You guess a 5-letter English word, and you try to get to the correct word by getting different colors to guide you to the correct answer. Let's get started. Okay, sup guys? Welcome to today's show. So today we're gonna create a Wordle game. And in order to create a game like that, we need to have a lot of words of 5 characters. So let's begin by going to Google and let's search for English words txt, and we scroll down to the this one, University of Michigan, and then we download this link right here. Copy link, and let's go in here and let's set the home directory to current working directory, and let's wget this file. So if we open this up in VI, we see that we have all these annoying Windows new lines. So let's use call to remove that. And then we have word list dot. Let's also sort and unique them. And then we have a word list dot txt. And we check the head. Seems okay. We check the ending. Right. And we open up in VI. And let's remove this empty line here. And what else do we do? Okay, guys. So now we have our WL.txt, and if we check how big it is, it's 69,000 lines. The next step is to only use the 5-letter words, right? So in order to do that, we need to do a little bit of regex magic, regular expressions. And since this is a beginner video, I will try to make the easiest regex possible. Alright, so we use the grep command and we add dash big E to use the extended regular expressions. And what do we put here? Well, first we begin the line. So think of the file. We begin the line inside of the file. And that was this caret thing means. And then we can have a dot. A dot means any character. And we want 5 characters, right? So the naive way would be to do just dot, 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 dot. 5 dots. And then we need the end of the line. So this ought to collect only the 5-letter words from this word list. Let's see if it does that. So WL 5-letter words. .txt. And we do a head of that new file. That seems okay. And we do a tail. And my understanding is that if the head and the tail looks right, then it has probably worked. But we can use the more command as well to be more certain. So you press space to go down one line. And a lot of these seems almost like random characters, but every single one of them is a legit English word. What did we have there? I saw a hole somewhere. This. CME. Why did we get that one? That's very odd. You know what we can do? It seems like only some of these words, like a very small amount, is not 5 letters. So let's, instead of digging into more regex magic, let's just add a function in our code that checks that the word is 5 characters. Otherwise, it will just skip that word. We can also do something like sort dash big R in this file. And we put it into wordlist.txt. We clean up the ones we won't use. So that's WTL, TXT, and the W file. So find one last check. We do the head of the word list. Sounds okay. Besides that head, perhaps we did match on words that are already less than 5. That's probably it. Never mind. So yeah, I might have a solution, but in my head, but I don't want to dig into that right now, because that can be pretty time-consuming and advanced. So let's see. We will also check how many words we have. Alright, 5,000. That's probably so every user of this game will never see a duplicate, right? Okay, so let's see. Let's begin coding then. I have already prepared my VS Code directory right here, and I'll create a new file which is called WHILE.C. And I will not use an H file this time. I will only use one single file. And this is the WHILE.C. And let's see. I think I can minus once. And I need to resize this window a little bit. Yeah, good enough. Okay, I hope you see this. So we have the WHILE.TXT, and let's include all the things I usually include. So we have standard IO, we have UniSTD, we also include std.lib, and finally we include string. And that's it for now anyway. Alright, so what do we need? Well, we need a function which is able to check if the character in question, so it checks one character. Let's say the word is apple, and the user provides the letter A. Then we want to highlight that this A is in the correct place. And maybe next time he supplies, he does supply another word. So what should we take? Canon. So C is not there. The A is there, but it's at the wrong place. So this will be yellow, right? And yeah. And then he might do something like, I'm trying to figure out a 5-letter word beginning in A. What about atoms? Then the A will be at the correct place. We have no T, we have no O, no M, no S. So that's how it's supposed to work. We will have one function which checks one character, and then we loop that for all the 5 and presents a result. But first, let's define a simple structure. So let's call this word, S-word. S is for struct, by the way. And a struct is a blueprint for an object or your own defined data structure. So you take several variables and you push them into one unit. And why do we need this? Well, first of all, we will need a string. So let's call this the actual word. And this doesn't have to be bigger. Let's do 8. It will be 8 anyway, because they can't be any smaller, right? Alright, so we have the word. What else is interesting about this word? Do we need some more instructions? So each word will be saved in memory, and we will also let's have a size. let's just do, I will try to do as simple variables as I can, so no unsigned into 16 bits, etc. So let's have a size, but it will always be 5, right? I don't think we need this struct at this time. We might need one for the guess later on, but not currently. So instead, let's just create the main, by the way, so we will be able to compile this at some point. Like so, and let's be vigilant with the function definitions, because that is a good practice. So as soon as you define a function, make sure to create the function definition as well. And basically, it's the first line of the function, but with a semicolon at the end instead of this bracket. And you put them all at the beginning of your code. Alright, let's just compile it. So we do GCC, and we don't need any we can have wall, by the way. WALL means that we get all the extra warnings and stuff. That can be good. And we have the WHILE.C, and we want the output to be Wordle. Okay, no problem there. Okay, so let's create this function that checks one single character. So we can begin by doing the signature of the function. So, and what should it return? It should return, that's what I was thinking about earlier. I will show you. I want this to return a result, right? And I'm going to show you what a result is, or what it will be. And let's call this function check char, perhaps, or maybe just cc check char. And what does this function need? It needs 2 characters, right? It needs the actual correct words character, the one we are comparing. So let's call this correct. And then we have the guess character. And that's basically it, I think. Perhaps we do need the, let's see, we need the index as well. So let's do int idx, that's short for index. And then we will need the actual word as well. So the word will be, let's see, the word will be a char pointer. I will try to avoid pointers, but in this case it's a string, so that's always denoted as a pointer when you call a function with it. Okay, so this is the the word in question. We need that in order to figure out if the character is in the correct position. And let's do the, okay, let's move this up to here. Make a little space, and let's see. Okay, let's create the function definition right away as well. So we have cc, and we send a char, and we don't give the name of the variable here, we just give the type. And we have another char, and then we have an int, and finally we have a char star, right? And we also need to define this result, and for that I think we do need the struct. So sResult, and what do we want to return here? So let's see. We want to say one of three things, either if it's green, yellow, or red. So let's just call that color, and let's define the colors as standard definitions. So result green. Let's do that 0, and let's define result yellow as 1. Let's start by 1, by the way. Then we can have this as 2. And then we have red, and let's do 4 for that. And why 4 instead of 3? That has to do with flags and stuff, and I don't want to get into that in a beginner video. I have good other videos about that exactly. Okay, so we send back the color, and do we need to tell the main program something else? Yes, we need to tell the main program what index the different results are connected to. Maybe we should return 5 results. Or at least 5 colors. Like so. And yeah, let's do it like this. And then we use typedef just to make it give it a suitable name. So what we want to change is the struct as result, and we want to call it result with a big R. And that is what we are returning here. Okay, I think this will work. So at this point we're only gonna return one result. Are we overcomplicating this? Let's just do this instead. Type of struct, instead of doing this as a struct, I still want the result, but let's just make this a char, because then we can use these definitions against this char instead. So that means that in this case we return one result, but in another case perhaps we will return several results. So we can even annotate that by doing type def result 5, because we only ever gonna need either one result or 5 results. So let's call this results with an S at the end. I think you can do this. Okay, enough of that. Let's begin creating our function. So basically we will have a single switch statement here, and what we want to check is the word, but we want to check the IDX position. So if that is 0, we will check the first character in the word. And what different possibilities can we have? We can have the same. So we can have a case for correct. I don't think we need to have this guess parameter, by the way. So this is quite usual when you code. You optimize it step by step when you figure some other better solution out. So let's remove one of the chars here as well. So okay, so if we pick the correct one, and then we will return. I wonder if you in the last C version just can do something like right, it's not a struct, never mind. So we will simply return one of our constant definitions, and that'll be result green, because if we pick the correct letter at the correct place, then we can just return that. What else do we have? We have a, let's see, we can have a default where we check with an if statement if the let's create a function called isIn, and we do correct. So if the correct if the guess okay. Instead of correct, I think it will be better to have the guess back. So let's define our correct. What just happened? Let's define our correct right here instead as a regular local variable. So the correct character for that position will be the word at that index, right? Okay. So if the let's see, if the correct character is inside of the word, but since we are at the default branch, it will not be at the correct place. But if it's inside the word, then we can also early terminate. We can return result yellow for that position. And in all other cases, we can denote that by just going outside of this. Since we return in both possible cases, we can just return the other thing right here. So that will be a return, and let's see, red, like so. And okay, then we have a CC function, you guys. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, welcome back everyone. Let's continue with our Wordle game. So this far we have written a function which will take one single character from the guess and compare it to the different possible results. So it can be either green, yellow, or red. Now we want to write a function which takes the entire words and calls this function 5 times. So let's begin by defining the signature. This one will return results. So that is 5 units of the result type. And the last function was called CC for check char. Let's do this CW for check word. And what do we need here? We need, let's see, let me just check something. Correct equals word at index switch. I think we might have made a mistake here. What we want to compare is the guess. So the guess should be checked against it if it's correct. Let's see, if the word is the correct. And in here we ought to do the same, right? So we should check the guess against the word. Alright, that's better. Alright, so let's see what we need here. We need the entire guess word, and we need the entire correct word. So let's name it the same, but this time we'll put a star in front of them. So we take the guess, and we take the word. Like so. Let's give us a little bit of space to work. And we need some kind of result variable. So let's do results res. And we need an integer as an index to go through all of these characters. And let's see, that should probably be enough. Let's try it. Alright, so we start index from 0. At each iteration we want to check if I is less than 5, and then we increase I. And what do we want to do at each iteration? Well, we want to set the res I, so the current character that we are investigating, and we set it equal to our CC function. And what did it take? Okay, now we made the whole thing up here. Let's move it later. Okay, so we have a guess index word, and that is the correct word. So the guess will be guess I, because it's a character that we are investigating from the guess. And then we have the index, which is simply I. And we have the word as the correct word, right? Yeah. So when we create those kind of helper functions like CC, it makes it very easy to write functions like this. So let's simply return res, and we're done. And let's see, let's move this whole thing. Let's put it here. and then we create the signature. That was our intention from the beginning as well. So results and C word we called it, and it only takes 2 char pointers or 2 strings rather, like so. And now we have coded a couple of functions, so I think it's time to test our code a little bit. And in order to test the code, I want to create one more helper function. Let's call this, let's see, let's call this print, or let's add the prefix example so we can easily find it when we want to remove it, because this should not be in the finished product. This is only for us now. Okay, so the example, what does it do? It takes a let's see, we need a name for it first. So example print results, and it takes a results variable, like so. And let's move this up here, but let's also put it here, and then we give this a name, res, and what do we do? Well, we have the results, we just need to go through the results and print it somehow, and we are going to print it more good looking later on, but at the moment let's just do some kind of naive implementation of this. So let's loop through the results. We set I equal to 0, I less than 5, I plus plus, and at each iteration, what do? Well, we do a switch of the results at that position. Right. And there are 3 different possibilities. So, case, we can have a result green. And in that case, we, let's see, we just print something like green. Let's make it easy. And we break. You always need to end a case statement with break or return, unless you want it to continue. And then we have the result yellow. Let's copy this line, paste it here, and type in yellow. And finally, well, let's break first. Finally, we have case result red. We'll do the same here. Break. And then we probably don't need a default statement, but you never know. Something can go horribly wrong sometimes. So in that case, we can print unknown, and then we print the integer value of res I. And at the statement at the end, you don't need break, but I usually put it there anyway, just out of habit, so I don't forget it some other time. Alright, and this is all this function needs to do. And we don't need this return statement, it's a void function, but I usually put it there as well. I like to have structure. Alright, so let's try this out. So let's see. Let's begin, by the way, by altering the signature of main a little bit, like this. And in here we put the argc and the char argv. We check if argc is less than 3. That means we did not supply 2 arguments. And then we print the standard error. That's just the default thing that you ought to do when you work with a command line arguments. So you print the usage, how it's supposed to be used. And it's usually done like this. Let's do this. Correct word, guess word. And then we give argv 0, which is our binary executable file, and then we return -1. So if we don't have the correct argument, this is printed and we quit. If we do have the correct argument, let's create 2 pointers. And I'm trying to avoid pointers, but in this case, it's a very easy kind of pointers, and it will improve the readability of the code. So let's create one for the correct. Let's just call it correct. It is the correct word. And then one for the guess. Set the correct equal to the first command line argument. We set the guess equal to the second. We also need one results variable. Then we set result equal to our check word function, and it takes the correct word and it takes the guess word and returns results. And then we can give this result to our example print results, res. So this should work, I think. There's probably some small bugs here and there, but the compiler will help us find those. Alright, so let's see what it says. We run the same GCC command as before, and we get a couple of errors. Let's see. Okay, it doesn't seem that typedef has a support for that kind of structures after all. Typedef result 5 results. What if we were to do typedef struct s result? I think we named it something like that. Or do we have it? Right, it's not a struct. It's a char. So this should be a char 5. That ought to be possible, right? Let's see. And we space down a little bit and do clear, and that's so it's easily found first or the last invocation of the command. And we go up, and no. Expected identifier or parentheses before that token. Before that token. Never mind. Let's not go too deep into this. Let's remove this and just replace it with results like this. That should work, right? I think we can do it in the whole file. I'm not sure if you have the Vim motions installed, but in case you do, if you zoom in a little bit here, you can issue the command %s and then a comma, and we want to change results to result like this. And we want to do it globally, but we want to confirm each and every one of them. Right? Example print result, yes. Results, CV, there and there and there. Alright, let's see what it says. Probably we need to, in some of these cases, by the way, let's go back here and we do result, one of these. Result bracket. So void example, this is right, I think, because it's a signature of a function. In this case, it should be the same. And there as well. But when we define variables, we probably need to put the 5 there. And same here. And let's that's it. Alright, let's see what the compiler says. Okay, expected identifier. It gives the same error, but result. Okay, let's do it the good old-fashioned way with pointers. It's very tough to totally don't use pointers. So let's do this a result star instead. So we search for result in the bracket. Same here, it's a result star. Result star. Here as well. And here, yeah, here as well. No, wait. Since we're defining a local variable result, right, in this case we need to do this. So that's my mistake. Like so. And I think we got them all, right? Like those Tamagotchi thingies. Okay. Case correct. Case label does not reduce to an integer constant. Interesting. Case correct. And what is correct actually? What line was that? 45. Correct is a char. Case correct. So it's not able to. Okay. Yeah, it's in the runtime. Yeah, let's totally scratch this. Case statement. And let's do, this will be an else if, and let's do an if statement instead. So if the guess, let's see, if the guess, and then is it char, is equal to the word at, or the correct character of the word. In that case, we return result green. If not, if this is in this one, then we return yellow, otherwise we return red. And we never created this is in function, by the way. So let's do that too. And this should be a boolean, either true or false. If this guess character is somewhere in this word, it should return true. So let's make this a bool is in, and what order did we put the arguments? The character is first and then the word. Perhaps we should also give it a no, let's do another way. Alright, so we have a char C and we have a string str. And let's create a result. Let's call it. Let's make it a bool. Let's call it ret for the return value, and it's false from the start. And we also need an int I. And an int size. We set the size equal to the string length of str, and that should always be 5, right? But we might reuse this function somewhere else. So let's do it in this kind of way. Then we loop I equal to 0. Then we loop as long as I is less than size, I plus plus. And at each iteration we only do one if statement. If the word, no, the str at this position is equal to the C. If so, we do two things. We set the ret equal to true, and we break. That's all, because it's false from the beginning, so we don't have to worry about that. And then we simply just return the ret. Right, I think this should work. And let's do a signature for this as well. We have char, no, we have bool is in, and we have a character, and we have string, like so. And also we need to include the booleans in that's std bool.h, like so. Alright, let's see what it says. Okay, we're getting closer. Return res, warning, function returns address of local variable, okay, 77. Let's see what it's about. So we return the res here, and the res is an array, right? I think it ought to be enough to make this static, so we save it in a place where the other functions will be able to reach it. Okay, that's one. What is this other one? Return -1, that is just a typo. 87. is the semicolon, and what else? Res equals to assignment to expression with array type, right? All this stuff is because we changed the variable type from, well, to pointers and stuff. 93, so we need to clean up a lot of different things. Okay, so res equal to blah blah blah. I think it should be enough just to make this a pointer to res. So we clear and we run GCC and it compiles without trouble. Alright, let's see if it works now. So let's see. Okay, we forgot a new line. And then it won't fit. Let's do this. Alright. So when we run this, and this is just the example because we will create a game out of this. But we supply it with the correct word and the player's guessed word. So let's see. We give it a 5-letter word. And what did we have before? Let's see. Let's do canon. And we need a guess word with some of these characters inside, at least, I think. So let's do nylon, the fabric. Okay, so the N turned red, or how should we read this? Let's see. It's a little bit weird because the N, okay, maybe from the reverse order, because the N turns green because it's, no, it's not at the correct place. What about the Y? Maybe we gave it the wrong order, because the Y, red, L, we do get different colors, but I'm not sure what it's based upon. I think we need to look over the code once more. And let's see, if we begin with this, the smaller function, CW. So we define a result, and we set the first of this result equal to whatever CC does, and we send the first letter of the guess. Seems right. We send the index I, that should be 0, and we send the word. And what did we give it? The word. Guess word. word guess. Okay, we mix those up. I hope that's the only error. Because the first thing should be the guess. Let's see. By the way, let's undo this stuff. So we send the correct word, then we send the guess, and this takes the guess and then the correct word. Okay, so let's change it here instead. Okay, let's try it again. I think there's something else that's wrong, by the way, but let's take that when it happens. So let's do this again. Canon and nylon. Okay, so the N we got yellow because the N exists here but not at the correct place. The Y is red because it's not here at all. The L is also red, not here. The O is green because we have O, and the N is green because we have N. It works. The most difficult part of the game is done. Now we only need to do the infrastructure around. So basically we need to read all these words from our list or text file, and we need to randomize the order somehow, and well, then we just need to present it to the player, and in a nice kind of way show the results, not like this, but with actual colors. And I want to do something like, if in this case if we base it on this guess, the N should be yellow and the Y should be red, L should be red, and ON should be green. And at the next line we should do something like this. So yellow, red, red, these are still unknown, and then we have ON already done, and then the user can guess again based on that. Okay? So that is the next thing we're gonna do. Okay, welcome back. Let's finish this game, shall we? The only thing that's left is reading from the file, getting all of these words, and randomize a word each time we pick, and then write the input-output kind of stuff. So reading from standard input the answer and printing the result. Okay, so where should we begin? Let's start by reading the entire contents of the file into a two-dimensional array. I think it will be the easiest way of accomplishing what we want, because we have, let's see, word list. We have 5,195 different words. So let's see. Which is the best way? Yeah, well, let's write the function. Let's call it, we don't know what it's going to return yet, so let's just do int for the time being, and we will call this read file, and we will supply it with a file, and also a number of items. So let's call this max. And let's make some room. We are going to need a buffer, and it doesn't have to be that big since all the words are very small. Let's make 8 characters, and let's see, we also need some kind of I as a counter, and we need a file descriptor, and let's make it easy for ourselves by using the fopen kind of syntax. So let's open the file first, and let's see later what we need to add. So we fopen the file name with read permission, and put the fd like this, and if not fd, then something is terribly wrong. So let's do something like p error fopen, and let's return for the moment -1. Alright, so that's this. I'm still considering what kind of data structure we're gonna use. Since we know all of the words is going to be 5 characters, I think the most optimized way would be to use dynamic memory. It's something that I actually wanted not to do because it might seem a little bit advanced. But if you don't really understand this part, I have a very good video on dynamic memory and MALLOC that you should check out. So let's see what we need. We need a char and it'll be a double star because it will contain different strings. So it's an array of strings. And let's call this ret because this is what we want to return, right? Yes. So char double star this, and then we can't really return -1 like that. Instead it'll be char double star 0. Yeah. Okay, if we are able to open the file, then we want to allocate the memory. So let's calculate the size first. Let's see. I wonder if it's possible to define it like this. We can try that. So ret should, no, we need to calculate the size first. So let's create a variable for that. It can be a regular int size, and the size is going to be the maximum number, and we need 5 bytes per variable. Yeah. So then we can malloc. We set ret equal to the char double star version of malloc. We allocate the size. If ret doesn't return something good, we close our fd, and we p error. P error is print error, by the way, so it prints the thing we specify right here together with the actual error messages from the last run function. And then we returned char double star 0. Alright, so at this point we do have our data structure. We need one more variable, I think. Now we can reuse the size variable. This is mutable C. Anyway. Alright, so we will read from the file into our buff, and the maximum size we're going to read is 7 bytes. I usually take this value -1. And where we're going to read it from? We're going to read it from fd. And then we're going to loop as long as this is true. So it's as long as it is able to read anything. I also want to zero out the buff. So we put zeros 8 of them. So it's empty and nice before we read into it. Okay, so now we can set size equal to the string length of the buffer, so the word that we have read. And let's see if we read the word canon. Or let's do nylon. We are also reading the new line, and we have this invisible 0 after. So we want to remove this new line. Size should in this case be equal to 6. So 1, 2, 3, 4, 5, 6 for this new line. And the indices will be 0, 1, 2, 3, 4, 5. So the 5th index, that is the new line, and that is what we want to get at, because we want to remove it. So string length returned 6, and we want to get at 5, so we take 6 minus 1. We can actually just make size 5 bytes instead. And then we take buff and we index into this 5 and we set it to 0. And at this point, let's see, before we do that, in case string length would return 0, then we're in trouble, because then we'll try to index into -1 and set it 0. So we need to check for that. So if size is less than 1, then we just continue. But by the way, before we continue, we need to clean out the buffer as well. Like that. Alright, so now we are protected. And now we have basically we take this new line and we create another of these 0 bytes. And this doesn't really count. So next check we want to do is if the size at this point, because it should be 5 if we have a 5-letter word, if size is not 5, then we will do the same as above. We will just skip this one. So we 0 out our buffer and we continue to the next iteration. But at this point everything is alright. We have the correct 5-letter word. Now we just need to copy it to our structure. And we could just let's see. We could just use string copy, but since we are only calculating 5 bytes for each of them in order to save some memory, We could do 6 and then we could just string copy the contents. But at this point it will be easier, although I think the easiest way is just to do this manually. There's only 5 anyway. So we have the return value at our current index. Let's set I to 0, by the way. We call it I, right? Yes. So this is the number of the word we're at. And this this word has 5 characters. So 5p, and it has number 0, 1, 2, 3, and 4. And we should just be able to set it to the corresponding buff. This is not the most beautiful code, but I think it's the right thing to do in this case. We could make a loop or something, but I don't mind. All right. Is there something weird going on with the indentations, by the way? They're inside this loop. No, it's just big. Everything is just big. What to do at the end? We want to num set our buff at 0, 8. We want to increase our n. We do also want to check that that thing we ought to do in the beginning instead. So at the beginning of this, no, and is good. After we have increased this, we check that n is less than max. Let's do like this. Let's check that max is less than n. So max should be, no, more than n. Max should be more than n. But if it's not, if max is less than or equal to n, we break. Alright? And when we are done with all of this, we can simply fclose, fd. I think it would be interesting to return how many actual words we managed to get, because some of them is not the correct size, right? So I think it needs to know that. Let's create a structure for that. Let's call it, so what is it we are returning? we are returning words. Yeah, let's call it words. And what are we gonna return right here? We're gonna have a char double star pointer, which points at the array. Let's call it array, or just R. And we're gonna have a return value of type int n. No, incorrect. No, n is good. Alright, and we type def this struct as words into words, like so. So what is this gonna return? It's gonna return words. And oh no, I'm at the wrong place. Wrong function even. Where did we put this? Right here, okay. So instead of char double star, we're gonna do words, read file, and ret. Let's keep it like this, and let's create a words. And what shall we call this? Words. So, well, that complicates our error cases. That's a little bit annoying. Well, let's do like if the pointer inside of the structure is 0, then we are returning an error. That's a good enough solution, I think. So in this case, what do? We set words equal to, can we initialize it like this? So we set the what did we call it? R equal to char double star 0, and we'll also set the n equal to 0. I think this is how it's done in the newer versions of C. And then we can just return this structure as a value. Something like that. And we need to do basically the same right here. So let's copy this. Should be afterwards. And let's do like this. Move this return. Let's jump this in a little bit. So we F close, we print error, words, blah blah blah, return words. And let's copy this again. And continue. And then, no. Oh, I lost my copy. Never mind, let's write this from scratch. It's a little bit different anyway. So we F close, we set words equal to a structure where we have a pointer called R, which should be equal to our ret, and our n should be equal to I, right? Yeah. And then we return words. And I have no idea if this actually is gonna work. I haven't used this kind of solution before, but it'll be interesting to see. So let's run GCC, and we get a few errors. Expected expression before. It doesn't like our initialization. Perhaps that's because we used the wrong version. If we add standard equals C2X. No, still nothing. Probably we need to do that on the same line as we define the variable. I am not very fond of doing that. I think it goes against the C language somehow. But in need we do. So words equals, and words equals, and words equals. Okay, a lot of the errors and warnings disappeared, but not all. Let's see, red equals char, malloc size, assignment to expression with array type. Okay, it doesn't really like that thing. I was kind of hoping that it would understand what I meant when I did this. No, when I did this. Okay. What if? Because the problem is, I think we could probably have done something like this, but that's not really helping because we need the 5 on the other side, And I doubt that this will work. Well, we could try. No, of course not. Alright, we need to do it the good old-fashioned way now. So, char double star ret, and will let's see, will this stuff still work? That is the question. It has no real idea how big this should be. What if we were to... Well, we know how big the file is, right? We could make this some kind of dynamic array. That is also a new feature that I haven't really experimented a lot with. But we could just define it as, if we know the max, maybe we can even do it like this. Max 5. And we don't make it a pointer. And we make it static so we can return it. Well, it could work. And since this down here is a pointer, we should also be able to do this, right? Let's see. We probably need to change some other stuff, but let's see what it says. And perhaps we need to specify a standard. So C2x, no, C2x. Storage size of ret isn't constant. No, it isn't, but does it really need to be? With all those what is this called? Varying length arrays and stuff. Well, let's make it easier for ourselves. Let's remove this and let's keep this as is, but let's go to the beginning of the file and let's define max as a constant of 91 of 5. That's the correct one, right? Let's see. Word list there. 5195. 5195. I don't see why this shouldn't work. But we had some other error somewhere. Boof. Right, we should not malloc it. If we're at it's a malloc stuff. We forgot to remove that. Since we're putting this on the BSS segment now, we should not allocate heap memory space. So all of this malloc stuff will be removed. Okay, almost there. N undeclared. N undeclared. Yeah, it should be I, not N. It should be I. And I. N equals I. Alright. And now we have one warning left. Initialization of char double star from incompatible pointer type char star 5. Are they really, though, incompatible? I don't think so. But, okay. Let's see if it's enough with A. R equals char double star. And we need the address of that thing. And we are compiled, ladies and gentlemen. So the next step is testing if this function really works. But this is a good place to stop for today, because we're already 2 hours into this episode. So next week we will finish this game. And if you like what you've seen this far, please like and subscribe. And thanks for watching, and thanks for today. Okay, let's finish this thing, shall we? Before the break, we created a new function which takes the whole file of 5-letter words, and it creates a huge two-dimensional array of it. So let's test this, see if it works. So what did we call the return value? I closed that one down. No, we don't have an H file. Let's see. We called it words, and it contains R and N, right? So what do we have currently? Yeah, we have these tests, and they worked. We don't need those anymore. Let's remove those, and these as well. Alright, so what do we need? We need one of these structures, right? So let's do words, and we let words be equal to, what would you call the function? Let me just see, where is it? Right here. Okay, it's read file, and the only argument it takes is the file name. So worlds equals read file, and the name of the file is wordlist.txt. So let's put it right here, and then we should get something back. And inside of this words, we need to do a check if words dot r, if that is 0, because then it has failed. So let's do printf failed, and else we want to print something from that array, right? So how do we do that easily? Because it is a pointer. Let's see. Let's go back up here. It is a char double star. And we created it as, let's see, this structure. So it's ret max and 5. So what if we create one of these? So if we do char and we call this, let's see, if we call this something like P for pointer, and we were to do like 5, then we would create 5 different pointers, one for each characters possibly. But I don't think this is the right way. Let's see what happens if we just print from it. The type system must get the information from somewhere. But we can start by printing the other variable, the n. That is a little bit easier because that's simply words dot n, right? And that is the number of entries in the array, or in the first array. What if we created 2 pointers? But we would still have to know how big it is that we do. So if we were to do something like what if we were to do something like, let's say A and something like A max, would we be able to point this first one to our array, select the word's number, and then point and dereference this one against it? Maybe we don't even need this step. Let's try this. P equals words dot R. Is this enough? Or do we need to do something like, no, we shouldn't have to. And if we then were to select one of these, let's say number 100, can we just print F number 100 percent S, and a new line? Can we just do P 100? Maybe we can. Yeah, let's try it. Hopefully we'll get some guidance from the compiler with regards to errors and warnings and stuff, and we'll take it from there. Okay. Assignment to expression with array type. Right. It does not like that apparently. But how do we then tell the type system how to use that one? P equals because it can't just work like this. So let's it remembers the form, the shape of that array, but I don't think it will. I don't. It did compile though. Let's see what happens. Segmentation fault. Of course. But where does it segmentation fault? Let's see. Read, close. It's probably inside of main. One of the last thing we did. Let's do an L trace as well. Quite a lot of these library calls. Let's see. Yeah. When trying to print this stuff. Just get a couple of random characters. We need to dereference that pointer, I think. So let's start there. So let's make this a regular pointer. Can we still do this though? Let's see what happens. We are experimenting a little today. So this is what I was thinking. Do we need a parenthesis? Perhaps something like that. What will happen then? We get the warning. Format present as expect. Argument of type char star, but argument 2 has type int. That's weird. Well, what happens when we try? Segmentation fault, of course. Is it at the same stage? Looks like. Let's think a little bit rational about this. What do we have here? We have a pointer to a pointer. Char double star. And we pointed that one. We pointed that one against this, the static char ret max 5. Ret max 5. Maybe we should take the easy way out in this case. I don't want to get into GDB debugging and stuff in the beginner video like this. So let's just make it easy for us. Let's see. Instead of returning words, we will return an int. and that is the number of words. Then we take this one and put here, so we make a global variable of this. We need to change it though. Let's call this words instead. Right. So let's see what else we need to change. We need to change this part because we will return -1 with an error. Right. So this stays the same. This too. And the result, instead of this stuff, all we need to do is return n. So we skip out all of this stuff with regards to structures and pointers and stuff, and we simply return the number of words, and then we have a global variable holding this data. I don't really like global variables, but sometimes it's the easy way out. They are, after all, allowed in the C language. So then we could just change this to words. Remove this. And this we need to, let's see. Let's remove this, create an int n, remove this, we set this equal to n, if words are no, in here we will check if n is less than 0, then we do this, otherwise we do this, and this will just be n, and the hundreds will be words 100. Okay, I think that should work, unless I did a typo or something. Okay, what now? Ret undeclared. Okay, we did rename it, but we didn't change that everywhere. Right, that's no big deal. Let's see. Let's go to the top. Let's search for ret. Preferably without getting the U afterwards. Like so. Okay, that is not the right one. Let's move on. Okay, here we are. So we want to change ret to, what do we want to change it to? We name this words. And let's set global. And then we should just be able to do S like this. Great. Let's search for the next ret without trailing view, and we are back up here. Okay, let's just skim through this function so we haven't forgotten anything. We have buff, I, size, FD, do this, we do that, and at this point we copy. Seems about right. We need to change the signature as well, by the way. So, okay, we haven't even created that one yet. So what do we have? We have int read file, and we have a char star, and that's it. Save. Okay, now it should work better. What is this then? N underline, yeah, it's not N, it's I. And we have something wrong at 117 as well. Okay, let's go into read file. Read file. Tough to spell read file today, apparently. Here we are. Okay, so where do we have this N? Okay. There. Should be I, and what is line 117? It's this one. Okay. I need to make this a little bit smaller. I will not be able to grasp this stuff otherwise. So let's see, the yellow one is the function. Then we have this, and that is closed. We have a while loop with purple. If statement with blue, done. If statement with blue, done. And this is the purple. And here we close the yellow function. So why did it complain then? Well, let's try again. That's weird. Did I forget to save? Okay, now it compiled. Fingers crossed. Okay, that is actually quite sensible, because we are not using the null terminated strings, right? So we can't just use stuff like printf, because it will printf the word we're looking for, and then it will print everything after that. But it seems to be working. It sure does. So just to test this out, maybe this is enough. Hope you can read this. To test this out, we may do something like this. So number 100. Let's just print this. And then we print f %c for character. And what character is that? it is the words, word number 100 and character first, like so. And we need 4 more of those, so 5p, 1, 2, 3, 4, and then we will just print a new line. And lo and behold, okay, this went a little off, but let's fix that. And there should be a new line here. And let's do 2 right here. Great. There we go. Word number 100, tiles. Okay, so that works now. That is fantastic. All we need to do now is create a function which does a random number between between 0 and the number of words that we have, -1. We had quite a few actually. 5195. Isn't that pretty much all of them? Yeah. Why does it not exclude the 3-letter words? Let's check something out. Word list. Let's. What is this? Okay, so is this why it? That's weird. Let's do a search for anything which is not A to Z. We have this. And there we have a dash. That's not good. But let's remove them as we see them. So off you go. This. And a parentheses. I can leave it like this because our program will remove the 3-letter words. So here's another, and here too. I wonder how many there are. Maybe we can do this all day. Let's save this far. And let's do a regexit instead. So let's do, we grep. Let's see. We grep all the words which are just A to C, and how do we write this? It should be 5 characters from word list. No, it didn't get all that much. There's always trouble with this repeat thing. What about A to C plus? No. And maybe we need to add the dash E. Okay, then it works. Does our first one do as well? Yeah, perfect. So let's pipe this to a new file, word list 2. Word list 2.txt. And let's do handle that file word list. It's annoying that both the program and the list begins with the same characters. Word list 2. And the tail also looks okay. How many do we have? Word list 2. 51, 72. Okay, so a couple went away at least. And if we were to go into the word list 2 and we search for any character which is not A to Z, we get nothing. Great. Okay, so this is what we want to use instead. Let's remove the first file. Word list txt and word list, and we remove the 2. Word list. And if we run our program this time, we have 5172. And we get another word, by the way. Great. So now it will be very easy to write a random function for this. All we need to do is, let's see, we want to return a string. And let's call this random word. And what do we want to give as an argument? All we need to give is the number of words. So int max. And we will just do something like this and create a, let's see. Let's create an X or something, and we call the rand function that we want it to be no bigger than max, like so. So now we have a random number, and maybe it will be the easiest to, but let's not settle for easy. Let's do this instead. Let's see. we create a string of 5 characters. So char ret 5. Then we copy manually like before. So ret and the number is equal to words x and the number, like so. We need 5 of these. So let's see, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And in order to make things a little bit easier, perhaps we should make this 8 bytes and add a 0 at the end, so we can return a proper string, right? And if we were to make this one a static char, then we probably should be able to just return it as is. So return ret. Okay, so this should pick a word randomly if we give it a max. Let's see, if we remove all of this stuff, or not all of it, but let's remove these printfs. And let's create a pointer p. So let's print f word and the %s. Let's put it inside of these quotes as well. And then we call our function. What do we call it? Random word. And we need to random word. We need to give it the n as the maximum, like so. And then we don't even need this p, because we call it directly. We need to seed the random generator though. So let's create a small seed function which will simply do x equals get pin. We take the pin and we use that to seed our random generator. And I will not go into the details of how that works right now, but if you are interested, please check out my random value video. It's one of the old ones with a ugly penguin. Okay, so we do seed, the first thing we do. Let's also create a couple of signatures. So we have seed, we have void seed, void, and we have in the char random word, and it takes an int, and that's basically it, I think. Now what? 11. Okay, this collides with what we named that argument, right? Let's go to random word, and we change this to something else. M. And where did you use it? Just there. Save. Let's try again. What is this? Words undeclared. Aha. We should move this up a little bit, because we created this variable right here. This. We created it down here. So instead, let's just put it somewhere at the top. So, like, there. Then we try again. Okay, just one small typo left. 151. 151, and we change this to a semicolon. Save. Oh, now I did save quit. Old habits die hard. Okay, and we go right here. We jump down a little bit. We try again, and this time it worked. And let's run our little game. And if this works, it should print out a random word every time. Servo, Dagan, think, chuff. Yes, it works. Very nice. All we have to do now is providing the infrastructure for the actual game loop, which shouldn't be very challenging, I think. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay, so now we have basically all the different building blocks. All we have to do is put them together, add a function or two, and create a game loop. So let's begin with the game loop. Let's do void game loop. And we are also going to create yet another global variable. And I'm going to call this, let's make it a bool. I will call it continuation. So this is gonna use it's gonna be used for the loop, basically. So when we start this program, what we'll do is we will seed the random number generator. We'll read the file, and we can change all of this stuff and just put in an assert that n is greater. Let's see. Let's do it like this. That n is not less than 0. Alright? Then we will set the continuation to true, which means we will continue looping. So while continuation is true, we will run the game loop like so. Perhaps we should feed the game loop one specific word. Let's see, how did I do that before? This is all the preparations. Is in random word. Here it is. And it takes in the max, right? Okay, so let's see. Max is this n. And let's create a char pointer, which we'll call p. And we will simply set p equal to random word, and we give it n. So now we have the word, the correct word that we're gonna guess, and we feed the game loop that word. So we add a char correct right here, and let's go to the top and do these function declarations. So void game loop, and we give it a char star like so, and let's begin by rewriting this example print results, and let's call it print results. And it takes a result star. Is that still what we use? Yeah, I guess it is. So print results. And we get the result from checking the word. Right. Alright, so let's go to the print result. Let's remove this. Let's see. No. Never mind. Alright, so what does this do? Case result green, result yellow, result red, and it just goes through each and every position. So we can use this almost the same, but instead of printing like this, I want to print like this. So we will have an S and then a char and then another S. The first being color green, the second being, let's see, res I. So we need the character. How did we make this result thing? Type def char result. Let's go into this CW function. So it checks the word. Static result. Okay, so it's an array of 5 characters. And it contains the colors. Because we need access to the words as well. I think we need to change the signature of this function. So print results. Let's take in the result, but also the word, also the correct word and the guess. So char guess and char correct. Because then we can do, let's see, color green. Then we have selected the correct letter. So let's put in our guess at the position I. And then color stop. We're going to define those colors a little bit later. And let's copy this to each instance. And remove this old ones. Right. So result yellow. And we're gonna have color yellow. And are we gonna print the guess, the character? In that case, yes, we are. Right. And then color stop and color red. It will be basically the same right here. And then we will simply end with a new line. Like so. let's see. We will also have some kind of prompt that looks a little bit like this. So how shall we do that? We need to save the correct guesses. So we can produce the prompt. And how do we do that in an easy enough kind of way? Well, let's say we have a function called prompt, which will take let's make it an int array. So indexes 5. No, not int. We can make this. Let's see. We can make this bool actually. Let's name this corrects. And it will look very similar to this function. So let's copy all of this and let's put this back. No, that's not right. There it is. And let's also put it in here, down. And we'll change what we need to change. So we iterate through these 5 characters and we switch for each one. We switch for the correct at that index. And then we will have 2 different cases. We will have case false and we will have case true. And that is if we have guessed that character correctly. So let's just print if we have false, then we just print a line, minus sign, remove this. If we have true, on the other hand, then we will print that character, which means we will need at least the correct word, correct of I. And we don't need this or the default. And then we print that. So we will have the corrects and we will have the correct word. That will be the prompt. And since it's a prompt, we should end with something like this. Perhaps we should have 2 new lines before it. Like so. And then we need to flush, because we're not ending with a new line. Okay, I think this will be good. So, void prompt bool. It'll be bool star, I guess. Char star. And bool star correct. The rest will not change. Oh, we need to remove. Need to remove that. This way we can always know which characters we have done. Let's see. Let's create another global variable, because we need to keep track of how many rounds we have played. Rounds. Let's go to the end, and we will set rounds to 0. Okay, so what do we do in this game loop then? Well, the first thing that we do is that we will actually do before the game loop, by the way. We will just print out 1, 2, 3, 4, 5, and a new line this, because I don't want to call the prompt before we have something to give it as an argument. std out. We have just started up the game at this point, but we'll still want to print something showing that we have a game. So the first thing we do is check if rounds is 0. If rounds is not 0, then we call the prompt. And what was the arguments? An array of bools and the correct word. So we need to keep track of this as well. Right. Then we should probably, it will be a lot of global variables, but I think it will be okay. Alright, bool corrects 5. And from the prompt we can erase this. We need to initialize the that as well. So correct, let's see, equals false. 5p. It's not very beautiful code, by the way, but it'll do the job. And then we can change this. So we don't need to print anything before the main loop. We don't need this if condition. We can just do the prompt directly with the correct word as an argument. Then we will read from the user, and let's real quick just create a read line function. So it's char read line, no argument, and we create a buff of size 8, mem set that buff with 8 zeros. We read into that buff, and we want to read only, let's see, we probably need 7 here. From the standard input, which means that we will have A, B, C, D, E, and then the new line and the 0. So we need a size. We set the size equal to the string length of buff. And then we check that if size is less than 0, let's do like this. Assert that size is bigger than 0. Alright, then we can do size minus minus. We can take buff size, set it equal to 0, and we can return buff. And we need to make buff a static, and then we have a read line function, which is safe, can't be buffer overflowed. So char read line, and let's see, void, like so. We go to the main loop, we go to the main loop game loop. Okay, so we prompt, and when we have prompted, we will read a line from the user. So char input and input is equal to read line. So when we have the input, we will need a result. And the result is equal to the check word. And what is the arguments for that one? CW. We take in the guess and the word. So the guess is our input, and the word is our correct, like so. Okay guys, let's continue with this program. I think we need to add a function, a validation function, because I just came to think about that the user shouldn't be able to input A, B, C, D, E, for example. It must be a valid word, or the user will lose one turn. But on the other hand, if the user or the player inputs bad input, like 2 characters when it's supposed to be 5, then I don't think they should be penalized with anything like that. So let's begin by creating a return type for this validation. So let's say we have validation OK, that is 0. Let's say we have validation bad input, that is 1. And finally we have validation no such word. So we use the same database with the 5,000 words that we use to randomly generate the correct answer for the game. We use that same database to validate that it is actually a valid word. I think that'll be good. So let's see. We can create type def. So type def char val result, and that'll be one of these 3 then. And then we create our function, which will return a val result, and let's call it validator. And all we need is a char star for the actual word that we have put in. Alright, so we will have a val result, and we name the function validator, and then we'll have char word. So first of all, we'll check the length of the word. So n equal to the string length of word. And if n is not equal to 5, then we early return, and we return the, let's see, val, what did we have? Val bad input. If it is 5 characters, then we check it, we loop through our database and we check if the word is in there. So we need, let's see, what do we need? We need some kind of counter. We can use that n again. But we do also need something for the actual loop. So let's do an I. Okay, so how do we structure this? We can't use string compare because it's not null terminated strings. So let's do something of like this. For I equals 0, we're gonna loop as long as I is less than max. And I++. Let me just double check this definition. Max 5195. Yeah, that's one. Right. So at each step we need to run our own. We need to run our own string compare. So let's do this. We set n equal to 0, and then we count how many discrepancies we find. No, we count how many similarities. How do we do this? Because we need to loop through the entire list. Let me see. Let's write this function call and let's see what it comes up with. Let's call it string compare underscore, since we can't do a prime, and we want to compare the, what did we call it? The database words. So we want to compare words I with the word, and let's say this string compare returns a bool. So if it's true, these two are equal. Yeah, we can do it like that. Let's create a bool which we call ret, and ret is equal to false. False meaning that the word hasn't been found in the database. So if these two are equal, what do we do? This doesn't look quite right. This is better. Okay, so if they are equal, we will set ret equal to true, and we will break. So that way we go through everything, and then if ret is true, everything is okay, we return val okay. Otherwise the word is not found, we return val no such word. Right, so now we only need to create that function. Let's make it a local one on the stack. So we need a, let's see, no, we can probably just do it like this. So bool, what did we call it, string compare, let's say prime, and then we have char str1 and char str2. And in here we can count the similarities. So S for similarities, S equal to 0 from the start. And then we can do a simple for loop where I equal to 0. We're going to loop as long as I is less than 5 and I plus plus. And if str1 I is equal to str2 I, then we increase the S. And that is probably all. And then at the end here we will return, check that S is equal to 5, because we need all 5 to match. And if that is the case, we return true. Otherwise, we return false. That ought to work, right? I think so, at least. So let's see how we will implement this in the game loop. First we prompt, then we take the input. We will have a val result, val res. So we set the valres equal to validator input, and then we switch the valres, and we have 3 possible things. We have a case val bad input. If this is the case, we will printf bad input, just like that. And then we will simply return by not doing anything else. Then we have the case of val no such, what did we call it? No such word. And need some spaces right here. Can't work at the bottom of the screen. And in this case, we're gonna print no such word, only 5-letter English words. Are permitted. Something like that. And now we need to increase the turns. Did we create a variable for that, or how did we do that? I don't remember now. Let's see. These are int rounds. Good. So let's see. Where were we? Game loop. And before I forget, let's go into the prompt and let's indicate somehow what turn we're on. So let's see, how do we print this? Just one of these. Well, let's just put it right here then. So turns. Then we go back to the game loop. And in this case, they have tried to breaking the rules. That's why we increase the turn, so they lose one shot. And then we return. And at the default case, if it's okay, we don't really need to do anything inside of the switch statements. Let's just put break here so it looks a little bit consistent-ish. Then we do the res equal to this, and we did add some global variable array, I think. Yeah, this keeps track of how many correct answers we have, and it must be the check word function which deals with that, right? So check words just checks through the correct ones and sets res I equal to cc and returns the rest. Okay, so we get the result from there. So we need to check through these results and update our res accordingly. Or perhaps we can do that inside of the check char. So what does this do? It's correct equals to word IDX. if guess equals correct, return result green. And we have the index, so we can just add one line here. Before we return, we set the corrects at index idx equal to true. And let's see, else if, and all are false from the beginning, and they can't go from green to any other color later on. So this is perfect for us. Okay, so we check the word. And then we need to count how many correct we have. So let's see, we need an int I, and something that counts how many are true. So for we set I equal to C equal to 0 from the beginning, and we loop as long as I is less than 5 and I++, and we check if res at position I is equal to, no, this is not it. What we want to check is if corrects at I is equal to true. And then we increase our C. And if C is equal to 5, then we have all the 5 correct letters, and we win the game. So let's say win equal to true. We will create this one, and then we just return. Okay guys, so let's continue. So if we have 5 correct letters, then we set the win to true. We will also set the continuation equal to false, which means we are going to break out of this loop. And then we will return from here. And let's see. We will also check if, or let's decrease, let's increase the rounds, and let's see. So at this case it's 0 from the beginning. When we have played once, it will be 1, 2, 3, 4, 5. So if rounds is more than 4, we set win equal to false, which will indicate that we have lost. We will set continuation to false, and we'll return. These are all the cases, I believe. So either we win, we lose, or we keep on playing. So let's define this variable. It would be a bool win. Let's also copy all of these global variables so we know that we have 0 initialized all of them. So let's put a comment block right here and paste them in. So let's see, corrects we are dealing with here. Rounds I think we have dealt with there. Continuation, I think we set it to true, yes. This we will deal with when we read in the file. So it's only the new win variable we need to take care of. So let's set win equal to false. And when we go to this ending right here, we want to print the correct word. Correct word was and we store that inside of P. And if win is true, congratulations, you won the game. Otherwise, you lost. Game over. Like so. And then we return 0. So what do we have left? It's only the colors, I think. But we can, if we define the colors temporarily, we should be able to fix all the errors. Let's see, so what did we have? We had color green, empty string, color yellow, empty string, color red, empty string, and then we have the color stop as well. That too an empty string. Alright, let's see what we have. Please note that we have created a lot of functions since we last compiled this thing. So we will have a lot of small errors which will be very quick to fix. But there might be a lot of them, so let's see. Here is the first one. Correct is undeclared. Yeah, I probably meant corrects. So this is on line 86. switch correct I. Yeah, it should be correct. So let's compile again. Arrow turns undeclared. Yeah, it should be rounds, not turns. So turns should be rounds, and turns should be rounds. And that's all of them. And then warning implicit declaration of assert, alright. We need to include that stuff. So we need assert.h. We need r_number.h, and we need to define underscore GNU source, like so. Line 242, we need to change to a semicolon. And then there's only one. Result res. Variable res set but not used. Okay, 249. 249. 249. Okay, so how do we check the results then? Do read line, we do the validator, we check the word, we set res equal to that, but perhaps we don't check the results. Actually we don't, and I don't think we need to either, because we use a different method with the corrects to check which letters we have locked in. And this is only for, right, it's for displaying to the user. We should add our print function. Let's see, what does it take as an argument? A result and 2 strings. First the guess and then the correct word. Alright, 249. So when do we want this to happen? We want it before this if statement and probably in between here somewhere. So let's do print results. We give it the res and the guess and the correct. I'm not sure what we call those variables in this function. Do we even have them? We do have the correct. Well, the input is the guess. So let's use that. Input. And now I believe it should compile. Yes, it does. But does it work? That's another question. In order to test it properly, we need to cheat and display the correct word. Otherwise, it will be difficult to test it. So let's do that. And one more thing. When we display how many rounds are left, I want to show exactly that, how many rounds are left. I do not want to show how many rounds, at what round we are. So this should be, let's see, it should be 5 minus rounds plus 1, right? Alright, let's see what we have. Okay, so correct word empty, and it displays a 6, alright? It shouldn't be plus 1 then. That's easy enough to fix. But it never displayed. Let's play around, see how it looks first. Okay, round 5. Correct word fraud. So let's input a too tiny word. Bad input. And we're still at round 5. What if we input something which shouldn't really be in the be a word? No such word, only 5-letter English words are permitted, and we are down to round 4. Okay, that looks good. So let's input a 5-letter word. What did we have previously? We had empty. Okay, it doesn't print much. Well, it printed empty, and we don't have the color highlight, so we don't really see what's going on. And all we get are these. But was any of the characters exactly right? No, I don't think so. What about if we take another word beginning with FR? So let's do Frank. Okay, this time we got 2 dashes. That's a little weird. What if we give the correct word? Okay. Well, the game seems to be working. We do, however, need to work a little bit on the presentation side of things, right? So, first of all, this shouldn't look like this. If we have 2 correct letters, we should see those 2 correct letters. And that ought to be inside of the prompt, right? And we are sending the correct word to prompt. We are switching the correct And if it is false, we print a dash. If it is true, we print the character at that position. Oh, correct. This should not be correct. This should be correct word. That makes sense. But when do we update this? Is it before or after? Well, it's a new round now, right? So it should work. Okay, let's try it again. That's a weird word. But let's see if we can figure out a word which ends in TA. Let's restart this. A back, okay. Abroad, perhaps. Abroad. No such word. Okay. And bad input. Yeah, we inputted 6 letters. Okay, we need to fix that as well. Okay, so let's see. A board, maybe. How do you spell that? Abort. Okay, so this time we did get those letters locked in. That's good. And that's probably as far as we can get right now. Let's do just this, this, this. Okay, so we're at round 0. Alright, so let's see. First we need to fix that 6-letter thing, because it showed both messages. How is that possible? Let's go to the game loop. So we switch for, if it's bad input, we return. And then no such word. There's probably some odd thing going on with the buffering and stuff. Perhaps we can let it be. Actually, we get 2 error messages and both are kind of, if not spot on, they're at least in the neighborhood of right. So let's not worry about that. Let's instead fix the last thing we have to fix, and that is the colors. So we are going to use ANSI colors, which are basically different key codes that affect your terminal. And I don't know these by heart, so we will have to turn to Google. So let's see, ANSI colors C. No, this is not it. Adding color to your output from C. The urban penguin. Here we go. So it's a slash and 033 and some other stuff. Right. So let's go in here and define our colors. 031 one of them should be like a color stop thing as well. Red, yellow, reset. There we go. So reset, that is what I call color stop. And then we just need to do variations of this string right here. Right, there and there. Okay, so green. What is green? Green is 32 at the end. And yellow, 33. And finally, what's red? Red, there, 31. All right, let's see how it looks. So, oh, that's a weird word. Let's try something. Let's see. Paste. Okay, so the P and the A is correct, and the E at the end is also correct, and same here. So the red ones are wrong. I want to try something. If we switch those two characters, then we probably won't get a proper word though, but let's do it anyway. Oh, all right. I want to see if the yellow works as well. So let's do something with B in it, but not this word, and not at that position. Let's do abort again. Ah, there we go. So we have 2 yellow and 3 yellow into red, which means that the yellow ones are in the word but at a different position. Okay, seems like this is working the way we intended to. Let's just remove our little cheat. And at the beginning, let's show a little message. And let's compile our final product. Of course, we introduced an error at the last second. And here it is. Our game is complete. Welcome to Wordle. Please enter a proper 5-letter English word. Good luck. So let's do abroad. No, that was 6 letters. Also 6 letters. Boomer. Okay, that was not in the list. And it's a 6 letters, okay. It's very difficult to find words on the spot like this. Colin? No. Okay, so names are not in the list. They usually aren't in these kind of games. Motel. Okay, the M is right, nothing else. Manga. Nope. Moped. Mumps. Okay, but it works. And how big did it become? Let's see. Oh, 323 lines. It grew bigger than I anticipated, and the structure is not so good as I anticipated either. But it works as intended, and it's safe and secure. Looks kind of nice. I hope you liked this video, and if you want to see more similar videos like this, please subscribe to this channel. Thank you for watching, and thanks for today.